OTC, same QC.
Go ahead, QC.
At this time I show sequence 19 complete and I'm back in 18.
Okay, copy. CHGD, OTC.
CHGD.
Okay, we're in sequence 30 at this time, ready for you to pick up a step 7 and 8.
Copy that, we'll put that in work.
Copy. Same QC, are you with us in sequence 30?
That's affirmative. What step was that?
7 and 8.
Copy.
GLS, OTC.
OTC, CDR, heading off of COM 9. I'd like to thank all the team for the excellent try today. We'll see you tomorrow.
Okay, CDR, we'll try again tomorrow. Better luck. Thank you. GLS, OTC.
OTC, TPE, we'll take in GLS calls.
All right, in sequence 30, steps 14 through 25.
Are those all performed?
No, I'm just kicking them off.
Copy.
TPE.
Go ahead, TP.
Yeah, we're giving GLS call on that.
Okay. EPD, OTC.
Here's EPD.
Okay, in sequence 30, the ground pig system securing step 51.
OTC, OVCC.
Go ahead, OVCC.
Yes, sir. The crew is in the white room. They're ready to leave the pad.
Okay, the Astrovan is downstairs. They can go on down.
This is Shuttle Launch Control at T-minus 3 hours and holding. We're in the final hours of the STS-32 launch countdown at this time. Here in the flying room at the Launch Control Center. Liftoff time for Columbia's 9th mission into space is planned for the opening of today's launch window at 7:35 a.m. Eastern Time. That window extends until 8:33 a.m. Eastern. We've got a full 10-day mission planned for this flight. Primary objective is to deploy the CENTCOM satellite, retrieve the long-duration exposure facility, and to demonstrate the capability of modifications for an extended mission duration. Total mission elapsed time will be 9 days, 21 hours, and 26 minutes with the landing at Edwards Air Force Base, California on January 19th. The only problem being worked at this time is a liquid hydrogen replenish valve on the mobile launcher platform. Within the hour, it was noted that there was some leakage at this valve, and we do have a red crew at the pad currently making preparations to begin tightening that valve. And then they will depart. We will go back into a stable replenish mode for the liquid hydrogen in the external tank, and then send the ICE team out to begin their inspection. At this time, the closeout crew is at the launch pad. They will be preparing the white room for the flight crew's entry. And the flight crew has been awakened in the last few minutes to prepare for today's flight. The red crew entry and tightening of the liquid hydrogen replenish valve is not expected to impact today's launch at all. This work can be performed in parallel with other countdown events. Again, the only problem being worked at this time is the fact that a red crew is making its way to the launch pad and will be tightening a liquid hydrogen replenish valve on the mobile launcher platform. After this work is performed, the red crew will then leave the pad, and the ICE team will proceed and go on with their normal duties of making inspections and taking temperatures and assessments at the launch pad. The weather for today's liftoff is favorable, with only a 10 to 20% chance of violating our weather criteria. Loading of the external tank was started last night, shortly after 11 p.m., and the event went without incident, after the tank was full, it was noted that there was some leakage past this replenish valve on the liquid hydrogen, for the liquid hydrogen system. And that problem will be taken care of here in the next hour. We're currently in a built-in hold at this time. It extends for 2 hours. We've got about an hour and 11 minutes remaining in this hold time. The countdown will resume at the T-minus 3 hour mark shortly after 4 a.m. today Eastern Time. Again, everything expected to go on schedule for today's launch for a liftoff at the opening of today's window at 7:35 a.m. Eastern Time. At T-minus 3 hours and holding, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. Now looking at some live coverage of the Red Crew at the launch pad. They're called the Red Crew because it is an unplanned activity to send this crew into the pad at this time. The only two crews that should be out there would be the closeout crew in the white room and the ice inspection team. However, we do need to tighten the liquid hydrogen replenish valve on the mobile launcher platform, and this crew has been designated to perform that task, currently climbing up the side of the mobile launcher platform. We are also standing by to receive live coverage of the flight crew having breakfast at the Operations and Checkout building in KSC's industrial area. Crew has been awake for about 20 minutes now, making their preparations for today's launch. Launch time for today opens at 7:35 a.m. Eastern Time, and it closes at 8:33 a.m. We do have the option for the full window today. We don't have any brakes or collision avoidance problems for today's launch window, so we do have the full use of the window. Gives more flexibility for any problems that might come up or with relation to the vehicle hardware or the weather. This is the liquid hydrogen replenish valve that will be tightened. Standing by for coverage of flight crew breakfast. And we've got the STS-32 flight crew again this morning for breakfast. Mission Specialist Marcia Ivins making her first trip into space today. Mission Specialist Bonnie Dunbar making her second trip into space. And Commander Dan Brandenstein. This will be his third flight, his second one to command. There's pilot James Weatherby and Mission Specialist David Lowe. It's their second day at sitting at this table with the traditional cake decorated with the patch for the STS-32 mission. And back at Launch Pad 39A, we've got the Red Crew on station on the mobile launcher platform, ready to tighten the liquid hydrogen replenish valve. Also, the closeout crew is at Launch Pad 39A up in the white room, preparing for the flight crew's entry. Flight crew should be departing the Operations and Checkout building in about an hour. Before that, they will be having a worldwide weather briefing. And then they will get into their flight suits and depart for the pad in the astronaut van. Should be arriving at the white room about 4:45 this morning. There's no other problems being worked at this point in the countdown. All other events are going smoothly. Launch team is on station here in the Launch Control Center. Countdown clock is at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. The Red Crew that was sent to Launch Pad 39A has now completed tightening the liquid hydrogen replenish valve on the mobile launcher platform. And now getting ready to leave the launch pad area. As soon as they leave, the lines will be chilled down and we will reestablish liquid hydrogen replenish. We will go back into liquid hydrogen replenish mode and look for any leakage at that valve. Don't expect any, but we will know as soon as we get back in to replenish here. In the white room at Launch Pad 39A, the closeout crew is preparing the orbiter's cockpit for the flight crew's entry. Flight crew should be at the launch pad in about an hour and 10 minutes. The NASA Select satellite will be used for the upcoming flight crew weather briefing. This is a routine event in the launch countdown, and the flight crew will be receiving a weather briefing on status here at Kennedy, at Edwards Air Force Base, at all of the transatlantic abort sites. So it's a worldwide weather briefing, get them up to date on the situation for today's launch. As soon as the weather briefing has been completed, we will resume NASA Select programming, and we'll be coming up with flight crew getting into their flight suits. They will have local coverage here at Kennedy only. Got about 40 minutes remaining in this built-in hold. We're now at T-minus 3 hours and holding. This is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. We've got about 25 minutes left in this built-in hold. Countdown will be resuming at T-minus 3 hours. The red crew has departed from Launch Pad 39A, and we are back into stable replenish on the liquid hydrogen, and we have no leakage past this valve, so all appears to have gone well with the tightening of the valve that occurred just about half an hour ago. We did complete with the weather briefing. We have the Johnson Space Center commentator on standby here. Will be giving us an update on the worldwide weather forecast for today's launch.
Center and the crew and the crew quarters at the Cape. The weather looks good around the world for the potential landing sites for the Columbia. This morning the weather at KSC looks very good. Scattered mid-clouds in central Florida, expected to clear out of the Florida Peninsula by launch time, with a condition calling for 11,000 scattered, visibility 10 miles, winds about 4 knots. At the RTLS sites, they're also looking pretty good. Ben Guerir at the moment has only a visibility of about 1/16 of a mile with ground fog, but they expect that to clear out by launch time, and are looking for a condition of 2,000 scattered and 20,000 scattered with good visibility. At Marone, at the moment, they have fairly good visibility, but they are looking for winds out of the east-northeast, 10 knots gusting to 15. The expectation being that they may be no-go due to tailwinds at Marone. The Banjul contingency landing site also looks good this morning. In the event of an RTLS, a TAL, or an abort once around, the landing sites would be as follows. At Kennedy Space Center, the RTLS runway would be 33. Columbia would perform a left overhead turn and would select a nominal aim point for a landing there. At Ben Guerir, the runway would be 36. They would perform a right overhead turn and select a nominal aim point there also. And the AOA site, or abort once around, Edwards runway 22. They do a left overhead turn into Edwards, and they're looking for low winds and good visibility there again. So the weather looks good around the world, both CONUS and transatlantic sites. And this is Mission Control, Houston.
This is shuttle launch control at T-minus 3 hours and holding. We've now joined the STS-32 flight crew in the operations and checkout building. They're getting into their flight suits once again today. Commander Dan Brandenstein. All flight crew members being assisted with the gear that they have to wear on the launch today. Mission Specialist Bonnie Dunbar. Mission Specialist Marcia Ivins, getting her headgear on. and Mission Specialist David Lowe. Flight crew storing their last-minute items they want to take aboard with them for the trip on the way up. These suits are pressurized and a little heavy, and crew does need assistance in getting into them. These are called crew altitude protection systems. They obviously consist of a helmet, a communications cap, pressurized garment. They're bright orange. And the crew wears them during ascent and re-entry. Meanwhile, back at Launch Pad 39A, the ICE team is making its way up and down the launch tower for inspections of ice or frost formations that could be a concern at launch time. Again, the liquid hydrogen replenish valve on the mobile launcher platform has been tightened, and we have no leakage at that point. We are back into a stable replenish mode on liquid hydrogen and liquid oxygen, and no problems reported at this time. Weather does appear to be go in here at Kennedy and also at Edwards and at the TAL sites. As soon as the flight crew finishes with their suit-up activities, they will be departing for the pad. Expect that to happen within the half hour. We have about 11 minutes remaining in this built-in hold at T-minus 3 hours and holding. This is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. Standing by here to pick up with the launch countdown in about 10 seconds. Now at T-minus 3 hours and counting. Flight crew is finishing up with getting in their flight suits at the operations and checkout building. We expect they will be departing for the launch pad in about 5 to 10 minutes. Got the closeout crew in the white room preparing for their entry. ICE inspection team is also making their inspection of the external tank and making sure it is ready for launch and there are no safety of flight issues. The ICE team is composed of 8 people representing NASA and contractors. Charlie Stevenson of Kennedy Space Center leads the team. We've got Greg Katnick, also from Kennedy, who is operating a portable infrared scanner measuring temperatures on various areas of the tank, boosters, engines, orbiter, and pad structure. Scott Higginbotham of KSC will be performing photo documentation of the vehicle configuration and cryogenic surfaces. He also assists in taking infrared data with the infrared scanner. Farouk Hunaidi represents Marshall Space Flight Center and will be measuring vehicle temperatures with a handheld infrared temperature measuring device. Close-up photo documentation of critical areas will be taken by Zach Burns of NASA at Johnson Space Center. Steve Copsey of Martin Marietta Michoud is the external tank manufacturing representative on the team. John Blue of Lockheed Space Shuttle Processing Team will be collecting data and correlating the infrared data. There's also a Lockheed safety representative on the team. The team carries binoculars and a telescope for greater resolution of detail on the vehicle. They wear highly visible orange protective coveralls that are anti-static and flame resistant. Everything continued to go smoothly since countdown began. Countdown did resume at the T-minus 11 hour mark yesterday afternoon, and the external tank has been refilled again for today's second launch attempt for STS-32. We expect to have an on-time liftoff this morning at 7:35 a.m. Eastern Time. That is the opening of the window. The exact time for the retrieval of the long-duration exposure facility will depend on the exact launch time, and all activities leading up to the LDEF retrieval will be determined after liftoff. There will be a briefing for media after the liftoff, and this will be gone over in some detail from the Johnson Space Center in Houston. at T-minus 2 hours, 57 minutes and counting. This is shuttle launch control. This is shuttle launch control at T-minus 2 hours, 56 minutes and counting. We're standing by now for live coverage of the STS-32 flight crew departure from the operations and checkout building. Flight crew is right on time this morning with their timeline and getting prepared for today's launch, which starts a 10-day mission. No concerns for weather today. Looking good here at Kennedy and California and also at the transatlantic abort sites. Looking at an aerial view here, the operations and checkout building. And back at pad 39A. Standing by for the flight crew departure from the operations and checkout building. They will be boarding the astronaut van for a 15-minute drive out to launch pad 39A. No technical issues are being tracked at this time in the launch countdown that would prevent an on-time liftoff. Still expecting that at 7:35 a.m. Eastern Time at the opening of the window. And we've got the flight crew, Commander Dan Brandenstein, Mission Specialist Bonnie Dunbar, Pilot James Weatherby, leading the crew out of the side door there. We've got the other two mission specialists, Marcia Ivins and David Lowe, being greeted by Kennedy Space Center employees, and we're wishing them well for today's flight. Pilot Michael Coates is also riding out to Complex 39 in the astronaut van. He will again be flying the shuttle training aircraft in the Kennedy Space Center area, making some real-time assessments of the weather for launch today. This is a standard event that we do have an astronaut flying in the aircraft to make an assessment of the weather. They will be departing momentarily for the ride out to the pad. It takes about 20 minutes. Expected at the pad's white room at about 4:45 this morning. Crew is all set to begin their 10-day mission, which includes deploying the CENTCOM satellite on flight day 2, retrieving the long-duration exposure facility, and also demonstrating the capability of the orbiter for an extended mission duration. And the crew, once again, making a trip to pad 39A. Today, looking at favorable weather conditions for a launch attempt. Everything is still going smoothly in today's launch countdown. No technical issues being worked. And weather at this point is cooperating. We're now at T-minus 2 hours, 51 minutes, 22 seconds, and counting. This is shuttle launch control. This is shuttle launch control at T-minus 2 hours, 30 minutes, and counting. The flight crew now at the white room at launch pad 39A. Commander Dan Brandenstein is being assisted now with the rest of his gear before boarding the orbiter Columbia. Brandenstein is a captain in the United States Navy and was selected as an astronaut in January 1978. He was born in Watertown, Wisconsin. He's making his third trip into space today. He was pilot for STS-8, which was the third flight of the shuttle Challenger. That was launched on August 30th, 1983. STS-8 was the first mission with a night launch and night landing. During that mission, the crew deployed the Indian National Satellite, operated the robot arm, the payload flight test article, and the continuous flow electrophoresis system. Brandenstein commanded his second shuttle mission, which was STS-51G. That was launched on June 17, 1985. On that flight, the crew deployed satellites for Mexico, the Arab League, and the United States. That was an AT&T Telstar satellite. With the completion of that flight, Brandenstein has logged a total of 315 hours in space. He received his Bachelor's of Science degree in Mathematics and Physics from the University of Wisconsin. He has logged 5,200 hours flying time in 24 different types of aircraft, and has completed 400 carrier landings.
You see this side, cell. Channel 2 and 2. Stand by.
Pilot James Weatherby is now being assisted with his gear. In the White Room, he's a lieutenant commander in the United States Navy. He was born in Flushing, New York. He was selected as a NASA astronaut in 1984 and is making his first trip aboard the shuttle today. Weatherby received a Bachelor of Science degree in Aerospace Engineering from the University of Notre Dame. He was designated a naval aviator in December of 1976. After serving aboard the aircraft carrier, the USS John F. Kennedy, he attended the Naval Test Pilot School and completed training there in 1981. He then worked with testing of and later flew the FA-18 aircraft until his selection by NASA. He has logged over 2,500 hours flying time and 345 carrier landings in 20 different types of aircraft. Once the astronauts board the orbiter Columbia, they will be performing voice checks with test conductors here in the Launch Control Center and also at Mission Control Houston with the flight directors and communicators there. Test director here at Kennedy Space Center for NASA today is Al Safji. And that's one of the people that you will be here talking on the air-to-ground communications loop that is being set out over NASA Select at this time. He's also talking to various members of the NASA team here in Flying Room 1.
ISL OTC 212. Is ISL 2 and 2? Yeah, we should have some personnel coming up on channel 145 in a couple minutes. All right, copy. We got our help. Thank you.
No constraints being worked at this time for today's launch, expecting an on-time liftoff at the opening of the window at 7:35 a.m. Eastern Time. At T-minus 2 hours, 25 minutes, 53 seconds, and counting, this is Shuttle Launch Control.
Implementation of SET 92, that's steps 422 through 429. Copy.
Go ahead, Sam. You can see on page 448.
Okay, are those steps going to be not performed for the note?
Okay, are we talking page 448?
Yes, sir.
I don't see any notes.
I'm sorry, sir. Page 648. Excuse me.
Yes, the 256 is not performed. Those steps are not performed.
Copy.
OTC CDR, sound check.
Morning, CDR. This is OTC.
Morning. Heard you loud and clear.
Read you the same, and weather looks good for today thus far, I think.
All right. MTD CDR, sound check.
Good morning, Dan. Read you loud and clear. How many?
Roger, read you the same, thanks. Houston, Columbia CDR, sound check.
Good morning, Dan. Houston, read you loud and clear.
Morning, glad to see how you guys are operating.
Yeah, we've been up for a while.
This is Shuttle Launch Control at T-minus 2 hours, 19 minutes, and counting. Mission Specialist Bonnie Dunbar is being suited up, getting ready to climb aboard the orbiter Columbia. She was born in Sunnyside, Washington, and will be making her second shuttle flight as Mission Specialist 1. She served as a mission specialist on STS-32, the West German D-1 Space Lab mission, and the first shuttle flight to carry 8 crew members. During that 7-day mission, Dunbar was responsible for operating the Space Lab and its subsystems, as well as performing a variety of experiments. She received a bachelor's and master's degree in ceramic engineering from the University of Washington in 1971 and 1975, respectively, and has received a doctorate in biomedical engineering from the University of Houston in 1983. Dunbar joined NASA as a payload officer flight controller at the Johnson Space Center in 1978. She served as a guidance and navigation officer flight controller for the Skylab reentry mission in 1979, among other tasks prior to her selection as an astronaut. She is a private pilot with more than 200 hours in single-engine aircraft and more than 700 hours in T-38 jets as a co-pilot. Just received a piece of information from Houston in the last 10 minutes that the long-duration exposure facility is just passing over the Horn of Africa. LDEF is approximately at an altitude of about 180 miles and is on its 2,370th revolution. LDEF was launched from the Shuttle Challenger on April 6th. It was on mission 41C. That was launched April 6, 1984. The LDEF is a 12-sided open grid structure. It's made of aluminum rings, and it's 30 feet long. It's 14 feet in diameter, and it weighs about 8,000 pounds. The LDEF will be retrieved using the robot arm. Once the rendezvous portion of the mission is completed, mission specialist Bonnie Dunbar will grapple the LDEF with the end effector of the arm and will maneuver it into the 5 support latches in the payload bay of Columbia.
Go ahead.
There's 57 different experiments on board the LDEF. They range in research interest from materials to medicine to astrophysics, and they all required free-flying exposure in space without extensive electrical power or data handling or attitude control systems. Most of the experiments are relatively simple, with some of them completely passive while they're in orbit. This LDEF structure was designed to be reused and returned to Earth. NASA gets updated information on the location of LDEF from the North American Aerospace Defense Command. We've got several secondary payloads on board Columbia. These involve material crystal growth, microgravity protein crystal growth, lightning research, in-flight cardiovascular changes, and effects of microgravity and light on the cellular processes that determine circadian rhythms and metabolic rates. There's no technical issues being tracked at this time. We're expecting an on-time liftoff at the opening of today's window. That's at 7:35 a.m. Eastern Time. At T-minus 2 hours, 15 minutes, and counting, this is Shuttle Launch Control.
CMTC.
Go ahead.
Okay, we got a new constraint at sequence 16-0903, flying item 403.
Copy.
You want the document?
No, I have it already, thank you.
I copy.
GLS OTC 212.
GLS 212.
Yeah, are you ready for step 540? Your initialization?
Yes, sir. We'll put that in work for the clock.
Okay, and I'll send you a QC over to channel 183.
Okay, thank you, sir.
CMQC OTC?
CMTC, I copy 183. OTC, CMTC.
Go ahead.
What step was that?
540.
Copy.
Try that. OTC PLT, comm check.
PLC, this is OTC. I read you loud and clear. Good morning.
Good morning, loud and clear.
Copy.
OTC GLS 212.
GLS.
Yes, sir. FTP dual interrupt notification will be activated momentarily.
Okay, and that's a step in your sequence?
That's step 541, 16.
Copy, thank you, GLS.
NTD PLT, comm check.
PLC, read you loud and clear. How many?
Loud and clear.
Good morning.
Houston to Columbia, PLT, comm check.
Good morning, Wexby. Houston is reading you loud and clear.
Good morning, Biggs.
CGSS OTC 212.
Go ahead.
Yeah, you ready for step 550?
Copy and work. OTC CGSS.
Go ahead, CGSS.
Yes, I can verify 552.
Okay, CGSS, that was 552 you just verified?
Yes, sir, that's complete.
Copy. CMQC 550 through 552 complete.
I copy.
OTC ASP.
Go ahead, ask.
All right, CDR PFT ingress complete, ready for post-ingress switch reconfig.
Copy. COFC OTC?
COFC, go ahead.
Yeah, can you give me step 479?
Okay, standby 1. OTC COFC.
Go ahead.
The 479 is complete. Also, there was a deviation inserted at that point. Can we check with CMQC to see if that's available? It's not going to constrain anything further other than exiting G9. But it's located at this point at a procedure.
Okay, CMQC OTC?
CMQC, go ahead.
Yeah, do you have a DEV on page 696?
That's affirmative. It adds step 478.1.
Yeah, that's the one. It's a DPS to do an item entry.
That's affirmative.
Wonder if we can get them to work that.
Is it 2 DPS themselves?
That's correct.
DPS OTC?
DPS?
Yeah, do you have a copy of the DEV on page 696?
That's affirmative. The DEV is complete.
Okay, copy.
Can OTC ask for holding up ingress until we get that switch reconfig done?
Yeah, ask, go ahead with the switch reconfiguration, remove the guards, and position RCS driver switches.
Roger, North. Roger, guards are removed, and the driver switches and ohms engine valve switches are both complete. Standing by for GPC output.
Okay, did we get the left ohms and right ohms engine valve?
That's affirmative.
And ask OTC panel 06, GPC 5 output switch backup.
Roger. That's complete.
CMQC OTC.
CMQC, go ahead.
Step 487 is not performed.
Copy.
CNSC OTC.
This is NSA, go.
Yeah, step 489, that's 118 X-ray still.
Copy that.
And I take it step 489.
OTC ask post.
Go ahead.
Roger, post-ingress switch reconfig complete. Caution warning, volume will be adjusted. Master alarm will be tripped.
Copy. CISL OTC.
This is ISL.
Yeah, did you copy ask? He'll be adjusting caution warning.
ISL copies.
OTC ask, caution warning, volume adjust complete.
Copy. CMQC, that's 496.
I copy, and we're all steps performed, 493 through 495.
That's affirmed.
Copy.
CMQC OTC.
CMQC.
Yeah, those were not performed.
Copy.
COFC OTC, can you verify 497 through 500?
I can verify that.
CT OTC.
TV, go ahead.
Yeah, terminate any change switch scan for step 501.
No, there were no changes.
This is Shuttle Launch Control at T-minus 2 hours, 2 minutes, and counting. Mission Specialist G. David Lowe just entered into Columbia's crew module this morning. He was born in Cleveland, Ohio, and will serve as Mission Specialist 3 today on his first trip aboard the shuttle. Lowe received a Bachelor of Science degree in Physics Engineering from Washington and Lee University in 1978. a Bachelor of Science degree in Mechanical Engineering from Cornell University in 1980, and a Master of Science degree in Aeronautics and Astronautics from Stanford University in 1983. He began his career with NASA in 1980 in the Spacecraft Systems Engineering section at the Jet Propulsion Laboratory in Pasadena, California. He participated there in the preliminary planning of several planetary missions and systems engineering design of the Galileo spacecraft. He's also worked as the principal spacecraft systems engineer for the Mars Geoscience Climatology Observer Project until his selection as an astronaut. Since he's become an astronaut, his technical assignments have included work with the robot arm and extravehicular systems. He also served as a spacecraft communicator during the STS-26, 27, and 29 missions. Mission Specialist Marcia Ivins is being assisted right now with the rest of her gear that she will need during ascent. She was born in Baltimore, Maryland, and will be making her first shuttle flight today as Mission Specialist 2. Ivins received a Bachelor's of Science degree in Aerospace Engineering from the University of Colorado in 1973. She began her career with NASA as an engineer in the Crew Station Design Branch at the Johnson Space Center in July 1974. Her work involves space shuttle displays and controls and development of the orbiter head-up display. In 1980, Ivins became a flight simulation engineer on the shuttle training aircraft and also served as a co-pilot on the NASA administrative aircraft at Gulfstream 1. She has logged more than 4,500 hours flying time in NASA and private aircraft and holds a multi-engine airline transport pilot license with a Gulfstream 1 rating, single-engine airplane, land, sea, and commercial licenses, a commercial glider license, an instrument, multi-engine, and glider flight instructor ratings.
3, 2, 1, mark.
She's the last astronaut to board the other.
Yeah, go ahead. ISOCOM flight on channel 145. Okay, stand by.
Sorry, Phil.
SPNTD, or SPOTC.
SP.
Yeah, we're going to go over to 232 and we'll pick up the next IPR on this breaker.
CISO?
Go ahead, ISO.
Yes, I just thought I'd let you know we're going to be picking up on our troubleshooting for IPR 235.
Copy that. What are y'all going to be doing?
Okay, we will be sending LBB commands.
Okay, copy. APUOTC 212.
Go ahead.
Yeah, could you come over to 232? We're going to pick up an IPR on that switch.
Copy. OTC, TBC, you down. SSB on 1212.
OTC, MS1, how do you read?
MS1 OTC, I read you loud and clear. How many?
Yeah, loud and clear also.
Copy.
OTC, TBC, 212.
Go ahead, TBC.
Yeah, can I have an ISL on 136, please?
ISL OTC.
Yeah, going to 136.
Copy.
OTC, CAPM.
Go ahead, APU.
Yeah, what channel did you tell us to report on?
That was on channel 232, and what we did is we picked up an IPR against your circuit breaker.
Copy that.
Being open. I need you to get with
NTD, MS1, how do you read?
ENTP on 161.
This is NTD on air-to-ground 1. Reach you loud and clear, MS1. How many?
Yeah, loud and clear also.
Copy.
TVFS OTC 212.
Houston, Columbia, MS1, how do you read?
Good morning, David. Houston's reading you loud and clear.
And Mike, you're loud and clear also.
OTC DPS.
Yeah, go ahead, DPS.
CVFS is on 232.
Okay, I was just going to send him over there. Thank you.
OTC GLS.
Go ahead, GLS.
Yes, sir. GLS functional initialization is complete. Sequence 62, step 92.
Copy.
And OTC OVCC.
Go ahead, OVCC.
Yeah, we've got the last crew member in there right now.
Okay, copy.
OTC SD 212.
Yeah, go ahead, SP.
Yes, sir. Can we talk to the ASP?
Sure. ASP, OTC.
STC to fast, go ahead.
Go ahead, SP.
Okay. ASPIS STE, talking with the VIT guys, we understand that the circuit breaker is open during the switch list and reconfigured by you during the pre-ingress switch list. Do you recall depressing that switch?
That's affirmative. It was confirmed. All 6 circuit breakers were put in and all were confirmed in. I think the people that watch those circuit breakers being put in, they can monitor that those in fact did go in.
Okay, so at a later time, you found that it was tripped or open.
That's affirmative. The PLT noticed it after he strapped in.
This is shuttle launch control at T-minus 1 hour, 47 minutes and counting. All flight crew members now aboard the orbiter Columbia. Closeout crew members will be preparing to close the hatch, and the flight crew will perform cabin leak checks. Some discussion going on about an open circuit breaker on one of the auxiliary power unit fuel tank valves, determining whether or not it was put in that configuration inadvertently, or whether it was just not put in the proper configuration during the pre-ingress switch list. There was no power on that circuit breaker through the night, so there's no concern over it tripping because of an electrical problem. There is some discussion going on at this time, and between engineers here in the flying room and pilot Weatherby. At the T-minus 1 hour, 55 minute mark, we had simulation of the first motion of the shuttle sent to the Johnson Space Center, the range safety and firing room, to test a system that indicates liftoff. This signal also starts the clock, which keeps track of the mission time. Heaters in the solid rocket booster hydraulic control systems have also been turned on. They will be used to start the decomposition of the hydrazine fuel, which is used to turn the turbine supplying power to the hydraulic pumps, which in turn allow the huge nozzles to be moved for steering purposes during the flight.
OTC, MS2, how do you read?
Good morning, MS2. This is OTC. I read you loud and clear.
You're loud and clear also. Good morning.
The astronauts are making voice checks with orbiter test conductor Larry Osterley here in the Launch Control Center. They'll also be making checks with Houston flight controllers later in the count. All events going smoothly for an on-time launch today at 7:35 a.m. Eastern at T-minus 1 hour, 45 minutes and counting. This is shuttle launch control.
The results that we wanted, and we're in the process of cleaning up the paperwork and removing the constraint.
Okay, so you're going to upgrade and close that IPR?
That's affirmed.
Okay, copy that. OTC ISO.
MPD, MS2, how do you read?
Read you loud and clear, MS2. How many?
You're loud and clear also.
Copy.
Houston, Columbia, MS2, how do you read?
Good morning, Marcia. Houston's reading you loud and clear.
You're loud and clear also, baby. OTC, MS3, how do you read?
MS3, this is OTC. I read you loud and clear. How many?
I read you loud and clear.
Copy.
All systems on 212, verified, ready for crew module closeout. CMQC, that's step 574.
Copy.
NTD, MS3, how do you read?
Read loud and clear, MS3, how many?
I read you loud and clear.
Copy.
Houston, Columbia, MS3, how do you read?
Good morning, Bonnie. Houston's reading you loud and clear.
Good morning, I read you loud and clear too.
OTC ASP.
Go ahead, Ask.
Roger, we're ready for the Astrocom and air-to-ground checks.
Okay, I copy, and I'm going to give you closeout crew module for flight.
Oh, roger.
CDR OTC.
Go ahead.
Yeah, CDR will pick up with the Astrocom checks, and we'll be going to air-to-ground too. Would you indicate when you're all ready to do that, please?
Roger, we're ready.
Copy that, going to air-to-ground too. CDR OTC, air-to-ground too.
CDR loud and clear.
PLT,
PLT loud and clear.
MS1,
MS1 loud and clear.
MS2,
MS2, loud and clear.
MS3,
MS3, loud and clear.
and CDR will be going to ICOM A.
Roger. Loud and clear. PLT loud and clear. MS1 loud and clear.
MS3, loud and clear.
Roger. Loud and clear for the CDR. PLT loud and clear. MS1 loud and clear. Roger.
CDR OTC, air-to-air.
CDR loud and clear.
Copy. PLT,
PLT loud and clear.
MS1,
MS1 loud and clear.
MS2,
MS2 loud and clear.
MS3,
MS3, loud and clear.
and CDR, that completes our Astrocom checks, going back to 212.
Roger, we'll see you there. OTC ASP.
Go ahead, Ask.
Roger, I'm ready to terminate comm between the ASP and the LCC at your go.
Yeah, that's a firm, and thanks for your support. CMQC OTC?
CMQC.
Yeah, that's steps 578 through 588.
Copy.
OTC CSS.
Go ahead, double F.
Step 572 is verified.
Copy, double F. All systems on 212. Astrocom voice checks are complete. 212 is available for normal use.
OTC, LVCC.
Go ahead, LVCC.
Yes, sir. ASP and SUTEC are out of the crew module. We're ready to proceed with hatch closure.
Yeah, that's a firm. You have it go. CMQC, that's step
I copy.
Columbia, Houston.
OTC, CMQC.
Yeah, CMQC, stand by. We're doing our air-to-ground voice check.
I copy. You were walked on that step you called in.
Columbia, Houston.
Go ahead, Houston.
Roger, getting ready to begin our air-to-ground voice checks. We'd like you to go ahead and configure for air-to-ground 1 voice check.
Roger, it's in work. Houston, CDR and air-to-ground 1.
Read you loud and clear, Dan. Wexby, how do you read?
Loud and clear.
Roger, read you the same. Go ahead and configure for air to ground 2 voice check.
Roll call. Houston, CDR and air to ground 2.
Got you loud and clear, Dan. How do you read me, Wexer?
Loud and clear, air to ground 2.
Okay, we got you the same. Go ahead and configure for air voice check.
Houston, CDR and air to air. How do you read?
Dan, read you loud and clear. Wexby, how do you read?
Loud and clear, UHF.
Roger, got you the same. Go ahead and configure for the SIMO voice check.
Go. Houston, the CDR on SIMO.
Roger, got you loud and clear, Dan. PLT, how do you read?
PLT, loud and clear.
Got you loud and clear. Wexby, MS1, how do you read?
MS1, got you loud and clear.
Got you loud and clear. David, MS2, how do you read?
MS2, loud and clear.
Got you loud and clear also, Marcia. MS3, how do you read?
MS3, loud and clear.
We got you the loud and clear, Bonnie. Thanks.
QC, OTC.
QC, go ahead.
To update you, 608-627 complete.
Copy.
OTC, OVCC.
Go ahead, OVCC.
Yes, sir. Hatch is closed and locked. Continuity check is good. Seal leak check is good. We're getting ready for 2 PSID leak check.
Okay, copy. QC 635-636.
OTC, CAFM.
Go ahead, Sam.
Yes, could I get the leak rate from the OVCC, please?
Okay. OVCC.
Leak rate was 0.
Copy that. Thank you.
OTC, ECL.
Go ahead, ECL.
Can I get the OVCC on 143?
Copy. OVCC.
Go ahead.
143 with ECL.
Copy. OTC, ECL.
Go ACL.
Need a CMQC on 143.
Copy. CMQC.
QC, copy 143.
OTC, ECL.
Go ACL.
We're ready for step 637 whenever you are.
Okay, we'll pick up that early.
Okay.
CDR, OTC.
Go ahead.
Stand by to perform cabin leak check.
We'll go standing by.
Okay, we're ready to pick up on that. Panel level 2, heading 1.
Go ahead.
Cabin vent. Vent ISO switch open until vent ISO talkback open and talkback close. You ready for 726?
Yes, I am. Stand by. QC, CISL.
Go ahead.
Ready for next pre-flight bite check.
Copy that. EPD, OTC.
The CPD.
Can you work 777?
Copy and work.
OTC, ECL.
Go ahead, ECL.
I'd like to go ahead and close the vent valve.
Stand by. Roger. It's 40.
02 and CDR, OTC, close cabin vent valve.
In work. OTC, CDR, cam vent valves are closed. Talkbacks are closed.
Copy. CMQC, that's 804 through 807.
Copy.
CTVD, OTC.
This PVD, go ahead.
Yeah, do you have to reposition vent doors?
Affirmative.
Okay, I'll give you step 813.
Copy and work.
CPD.
Go ahead, EPD.
Yes, I can verify step 778.
This is Shuttle Launch Control. We expect to have an on-time liftoff this morning at 7:35 a.m. Eastern Time for today's second launch attempt for STS-32. No concerns for weather today. Looking good here at Kennedy and California and also at the transatlantic abort sites. And we've got the flight crew, Commander Dan Brandenstein, Mission Specialist Bonnie Dunbar, Pilot James Weatherby, the other two mission specialists, Marcia Ivins and David Lowe, being greeted by Kennedy Space Center employees, and we're wishing them well for today's flight. Crew is all set to begin their 10-day mission, which includes deploying the CENTCOM satellite on Flight Day 2, retrieving the long-duration exposure facility, and also demonstrating the capability of the orbiter for an extended mission duration.
Houston, Columbia CDR, comm check.
Good morning, Dan. Houston, read you loud and clear.
Good morning. Glad to see how you guys are up already.
Yeah, we've been up for a while. PLT, how do you read?
PLT, loud and clear.
Got you loud and clear. Wexby, MS1, how do you read?
MS1, got you loud and clear.
Got you loud and clear. David, MS2, how do you read?
MS2, loud and clear.
Got you loud and clear also. Marcia, MS3, how do you read?
MS3, loud and clear.
We got you the loud and clear, Bonnie. Thanks.
T-minus 9.
T-minus 9 minutes and holding.
This is NTD on 212. Step 1009, say go, no go for launch. OTC, go. TBC, go. PTC, go. LPS, go. Mala, Mala's go. Safety. Safety, say go, no go. Safety's go. SD, SD's go. CDR.
CDR's go.
LRD. LRD's go. SRO.
We go for launch. Stand by for final clear.
Houston flight NTD.
This is flight. At the current time, we are go for launch. Observed in forecast weather.
That's for, I copy that. STM, are you go? STM, go. Okay, launch director, launch team's ready. I copy. Engineering director. All your technical community is ready to launch. Good luck and Godspeed. Safety, quality. Safety and quality have no constraints to launch. Payload operations director. Payloads are go. Copy. Cape weather.
Cape weather has no launch weather constraints violated.
I copy. Operations manager, launch director.
Roger, Bob. Poll the mission management team. We have no constraints, and you will have our concurrence to proceed with the launch.
Copy. Thank you, sir.
NTD SRO on 212.
SRO, go ahead.
You have final clear to launch.
Copy. NTD. Go ahead. Okay, well, looks like today's the day, and for Columbia, go get them. You have go for launch. Understand, thank you.
This is Shuttle Launch Control. We've just had the final poll of the launch team, mission management team, and launch director. We have a final go for launch.
Countdown clock will zoom on my mark. 3, 2, 1, mark.
T-minus 9 minutes and counting.
Auto sequence has been initiated.
Ground launch sequencer has been initiated.
PLT, OTC, configure fuel cell essential bus source switches.
Roger, connecting essential buses. And that's complete.
Coming up on retraction of the orbiter access arm. T-minus 6 minutes, 45 seconds. Just a few minutes, Pilot Weatherby will be given a go to perform the auxiliary power unit pre-start.
PLT, OTC, perform APU pre-start.
As APU pre-starts, then work.
Activation of the APUs will come at T-minus 5 minutes. These auxiliary power units provide hydraulic power to the orbiter.
And APU pre-starts complete. 3 grade talkbacks.
T-minus 5 minutes.
Yeah, let's go for orbiter APU start.
We have a go for APU start.
Perform APU start.
APU starts and work.
CDR reconfigure heaters.
CDR will go. And APU start is complete.
Final purge of the main engines now underway. The chamber coolant valves on the main engines are being opened to prepare for engine start. T-minus 3 minutes and counting.
PLT, OTC, clear caution warning memory. Verify no unexpected errors.
T-minus 2 minutes, 30 seconds. Now retracting the gaseous oxygen vent hood away from the vehicle, back to the launch position.
And caution warning memory is cleared.
Copy, and flight crew, close and lock your visors and initiate O2 flow and have a good flight.
T-minus 1 minute, 57 seconds.
Roger, that's in work.
We've had a go for liquid hydrogen pressurization to flight level. T-minus 1 minute and counting. T-minus 45 seconds. T-minus 31 seconds.
Let's go for auto sequence start.
We have a go for auto sequence start. Columbia's 4 redundant
25.
computers have primary control of critical vehicle functions for the remainder of the count.
20.
T-minus 20. T-minus 15. T-minus 10. 9.
let's go
We have a
for
go
main
for
engine
main
start.
engine start. 5, 4, 3, 2, 1, 0. Booster ignition and liftoff of Columbia.
Columbia ascending from the tower. Hand over to Houston complete. Roll program initiated.
Roger, roll, Columbia.
Good roll confirmed as Columbia heads out on the proper launch azimuth for the race to catch LDEF. Now throttling down through 102% for the passage through maximum dynamic pressure. They'll take the engines down to 65%. 3 good APUs, 3 good fuel cells. 3 engines now at 65%. Downrange 2 nautical miles. Now throttling back up, 3 at 104.
Columbia, go with throttle up.
Roger, Houston, go throttle up.
Now 12 nautical miles downrange, velocity 3,200 feet per second. 3 good main engines, 3 good fuel cells, 3 good APUs. Standing by for SRB staging. SRB separation confirmed. Performance nominal.
Columbia, performance nominal.
Roger, Houston, nominal performance.
Columbia, 2-engine Ben Guerrier.
Roger, Houston, 2-engine Ben Guerrier.
Columbia can now make the Ben Guerrier transatlantic sight if 1 engine should fail. All systems clean aboard Columbia. Now downrange 80 nautical miles, velocity 5,700 feet per second.
Columbia, negative return.
Roger, Houston, negative return.
Means Columbia can no longer perform a return to launch site aboard.
Columbia, press to ATO, select band jewel.
Roger, pressing the ATO, selecting band jewel.
Columbia could now press to an abort to orbit with the loss of a single engine. 3 good main engines up at 104%, downrange 223 nautical miles. Relative velocity 10,190 feet per second.
Columbia, droop band jewel 109.
Roger, Houston.
That call means Columbia could make the Banjul landing site with a loss of 2 engines by pressing the third to 109%.
Columbia, press to MECO.
Roger, Houston, press to MECO.
Press to MECO means Columbia can go to main engine cutoff conditions.
Columbia, single engine band jewel 104.
Roger, Houston.
Now 360 nautical miles downrange.
Columbia, single engine press 104.
Roger.
Columbia can make main engine cutoff conditions with 1 engine at 104%. Downrange 450 nautical miles now. Good navigation reported aboard the ship. MECO predicted at 8 minutes 32 seconds mission elapsed time. Now at the 23K mark, 23,000 feet per second. Engines throttling back for the 3G limiting. Climbing 248 feet per second. Downrange 697 nautical miles. Standing by for main engine cutoff. Main engine cutoff confirmed. Booster officer reports ET separation.
Columbia, nominal MECO, OMS 1 not required.
Roger, we copy that.
Preparations in work for the OMS 2 burn. The hunt for LDEF began at launch. This burn coming up will send us further toward that goal and provide the right conditions for multiple maneuvers to follow over the course of the next few days as we rendezvous with the long duration exposure facility.
Columbia, Houston.
Go ahead, Houston.
Roger, Columbia, you have a go for payload bay door opening.
Okay.
We see both doors open now.
And Houston, we've got good indications on the doors and good times.
Columbia, Houston, you have a go for orbit ops. Also want to recognize another first in space. 3 maggots in space. We're already worried about the food red line.
Oh, Roger. We acknowledge that first, and we're well aware of it when we planned our food rations initially, and they're well under control.
That's good to hear.
Maggots is a nickname of one of the recent classes of astronauts. One of the popular classes, well known for their desire to eat well and sleep deeply, and that's a name that has followed the members of that class around for the last several years.
Mission Control Houston, we're now taking live television from the payload bay of Columbia as the robot arm hangs poised above the payload bay. The RMS is currently being checked out and verified for operations by Mission Specialist Bonnie Dunbar. Columbia now on the ascending node of Orbit 4. Crew aboard Columbia beginning to unstow the cabin equipment and set up shop to conduct a variety of secondary payloads and experiments today, including protein crystal growth, the flight echocardiogram experiment, as well as the fluid experiment apparatus equipment. All quiet aboard Columbia right now, and as well as here in the flight control room. There are no failures or system anomalies that are being investigated or worked at this time, with the exception of a failed off S-band FM communication system. There are really no problems to report. The redundant FM system was selected and is working well. Don't expect that to cause any impact whatsoever on flight. This is Mission Control Houston at mission elapsed time, 4 hours and 38 minutes. We're standing by for continuation of that live downlink television from the payload bay of Columbia as Mission Specialist Bonnie Dunbar continues to check out the remote manipulator system and verify all the operating modes for grapple and berthing operations on flight day 4. This is Mission Control Houston. We're again taking live television from the payload bay cameras aboard Columbia. This black and white camera looking up from Columbia's payload bay directly into the end effector of Columbia's robot arm. This color view from the wide-angle color camera at the forward starboard position in the payload bay as Mission Specialist Dunbar forges into the RMS checkout timeline, having already completed the single drive test, the backup drive test, and currently conducting the direct drive test. The direct drive checkout is intended, in addition to verifying the proper operation of the direct drive mode, to give ground support folks here in the flight control room a chance to look at some of the RMS telemetry and assure that each joint is functioning properly, i.e. that the joint is reaching a steady state in a given frame of time. This is Mission Control Houston. We're continuing to take live downlink television from the payload bay of Columbia as Columbia tracks overhead the Baja Peninsula and the Gulf of California below. And meantime, Mission Specialist Dunbar continuing to put the robot arm through its paces. Currently in the direct drive mode checkout. The direct drive is a operations mode that bypasses the controller interface unit and the general purpose computers and provides direct drive command to the motor drive via hardwires from the hand controllers. This is a contingency drive mode, one that would be used in the event that the controller interface unit or the GPC has a problem. And also gives us a chance to look at variable numbers and joint rates as opposed to the automatic modes.
Columbia Houston, that Tech 76 comm message that you've got is a camera overcam.
Yeah, we got it. It's camera D. We're going to turn it off. We're working it out.
Columbia, Bonnie, you can go ahead and just turn off camera D.
Okay, we got it.
This is Mission Control Houston. They had expected live downlink television interrupted due to camera overtemp. The crew recognizing the overtemp on camera Delta, the wide-angle color camera, and necessarily powered that camera off. I'll need to leave that camera off for 30 to 45 minutes, allow it to fall back within acceptable temperature limits, and can begin using it again. Meanwhile, on board Columbia, Mission Specialist Dunbar continuing to drive the remote manipulator system in the direct drive mode, verifying the drive capabilities in all axes and joints of the robot arm in preparation for the Flight Day 4 rendezvous and grapple. Other than that, air-to-ground circuit very quiet today as crew aboard Columbia and flight controllers are not chasing any significant anomalies at all, but setting up shop aboard Columbia to get after the secondary payload schedule, which involves activation of a number of crystal growth experiments, the flight echocardiogram experiment, as well as activation of the CMCR, or the bread mold experiment. Meanwhile, everything going very well with the RMS checkout. No problems to report as of yet. Mission elapsed time 4 hours 54 minutes. This is Mission Control. This is Mission Control Houston. NASA Select Television is now originating again from the Johnson Space Center on the NASA Select satellite transponder, so those viewers at locations other than Houston have missed the opportunity to see some live downlink television from Columbia as Mission Specialist Dunbar puts the remote manipulator system through its paces, verifying all the various manual and automated operating modes of the robot arm in preparation for the LDEF grapple on Flight Day 4.
Houston, Columbia.
Go ahead, Columbia. Columbia, Houston, you caught us in the middle of handover to the east satellite. Could you repeat your last?
Okay, we'll just let you know we got PCG2 activated, and must have been a little torquing on that locker because we had a heck of a time getting the door back on, but it's all on and locked up and at work now.
Roger that. We copy. We were trying to keep score with you on page 3-2 of the checklist, the flight plan, and if you could update us on some of the other DSOs and secondary payloads as you get those done, that'd be great. And just a note on the aft pivot position toggling that you were seeing before. The payloads folks have looked at that. They've seen it before on previous flights and expect no impact.
Okay, Steve, I copy that. Thanks.
This is Mission Control Houston. We're standing by to bring television in from the NASA ground terminal at White Sands. Unexpected downlink television from Columbia. This is Mission Control Houston taking live television from camera Bravo aboard Columbia's payload bay. This camera looking, black and white camera looking up into the end effector of the robot arm. Mission Specialist Dunbar continuing to put the robot arm through its paces. The big camera here used to look up into the end effector, giving folks here on the ground as well as the crew a straight, clean axis perspective on movements in the wrist joint during the check. Mission Specialist Dunbar has completed the direct drive check, part of the...
Houston, with words on the NPC burn.
Stand by.
This is Mission Control Houston at mission elapsed time 5 hours 4 minutes. Mission Specialist Dunbar has completed the direct drive test, part of the check.
Hey, Dan, our preliminary cut at the NPC burn looks like it'll be something less than 3 feet per second. We're estimating about 2.3 feet per second now, so it'll be an RCS burn. And the TIG looks like it'll be about a half hour later than what you see in the flight plan, estimating about 7:24.
Okay, we copied that RCS burn at about 7:24.
That's good copy, and we'll have the pad for you here in good time for the burn.
Okay.
This is Mission Control Houston. That last exchange between Commander Dan Brandenstein aboard Columbia and Capcom Stephen Oswald here in a flight control room regarding the phase change maneuver, or the plane change maneuver, planned for later on this afternoon. That maneuver is designed to, it's a lateral burn that will, intended to change the orbital plane of Columbia to more closely resemble that of the LDEF. That burn, originally planned as an OMS burn, is currently being planned as a RCS burn due to the excellent alignment and very close planar positioning between Columbia and LDEF at this time. Again, that burn coming up at 7 hours, 24 minutes mission elapsed time. It'll be a less than 3 foot per second burn, thus use of the reaction control system rather than the orbital maneuvering system thrusters. And Mission Specialist Dunbar continues to work the remote manipulator system through the RMS checkout. Having completed the direct drive test part of the checkout, is now well into the hand controller check. The hand controller check involves Dunbar manipulating each RMS hand controller in various axes in turn. The intention is to verify the hand controller command path and monitor the hand controllers for proportionality or for likeness in their response to input. Basically, the technique for verifying the command path and monitoring the proportionality between the controllers is simply by deflecting a hand controller in a single axis and slowly ramping the command in until the hard stop is reached, and that procedure is then repeated in all axes of each of the hand controllers on board. Again, a very complete and thorough checkout of the RMS in preparation for Flight Day 4's berthing or grappling, photo survey, and then berthing of the LDEF. Columbia now tracking high above the east coast of the South American continent at about 10 degrees south latitude, and beginning to track out over the Atlantic Ocean.
Columbia Houston for RMS, reminder on vernier rates.
And we got it, thanks.
Roger that.
This is Mission Control Houston. The checkout of the remote manipulator system continuing to go very smoothly. Mission Specialist Dunbar is pressing on through the timeline, and now in the manual augmented modes check, testing the ability of the GPCs and the hand controllers to work together in the crew cabin to drive the arm simultaneously in multiple joints at a time. We're about midway through the RMS checkout. So far, no problems to report. Everything looking very clean and tight. All quiet aboard Columbia and here in a flight control room. Not a lot of replanning activity, but flight controllers and crew alike getting ready to support a number of secondary experiment activities this afternoon. And preparing for a plane change maneuver to help place Columbia in a more like orbital plane to LDEF than it is now. That burn scheduled for 7 hours, 24 minutes mission elapsed time. They plan to use the reaction control system thrusters as less than 3 feet per second delta V is required on that maneuver. This is Mission Control Houston. NASA Select is now originating again from the Johnson Space Center and broadcasting on SATCOM S2R. That satellite was being used over the last 30 minutes or so to bring some live television through the NASA ground terminal at White Sands, New Mexico, from the shuttle Columbia, as Mission Specialist Dunbar continues to put the RMS through its paces, checking out that system and verifying its readiness to support RMS operations on Flight Day 4. Columbia now on the descending node of orbit 4. This is Mission Control Houston. Our next television event is going to be a replay of the RMS checkout television that we took live from Columbia during orbits 3 and 4 over the last hour or so. Those satellite viewers not located here at the Johnson Space Center didn't have the opportunity to see that television color converted and live, so we recorded it and are playing it back coming up in just a couple of minutes at 11:55 a.m. Central Standard Time. Again, our next television event is a replay of previously downlinked orbiter television depicting the RMS checkout activities in the payload bay of Columbia.
Columbia, Houston.
Go ahead, Houston.
For info, we're going to be commanding power off on S-band power amp number 1. If you need to use that power amp for any reason, it will require about a 3-minute warm-up. And also, when it's convenient, we'd like the readings that you got during PCS config on the cabin and the meter for cabin pressure.
Okay, Steve, we copy that. Stand by. Okay, Steve, just keeping you updated. DSO 471 has also been activated, as has 0623 some time ago. The pressures we got when we did the PCS config, we're showing 14.7 on the CRT, and looking at the gauge, it looks like about 14.9.
Okay, copy 14.7 on the gauge and 14.9 on the gauge and 14.7 on the meter, and we appreciate the update on the DSOs.
You didn't read it back the way I thought I said it, but I may have said it wrong. We have 14.6 on the CRT and 14.9 on the gauge, so I probably didn't say that right.
Columbia, Dan, after I read it back, I wanted it back. That's my mistake. We did copy the data. Appreciate it. Columbia, Houston, with a couple of questions on PCG2 activation.
Go ahead on PCG2.
Hey, Columbia, what we were wondering was if we could get a few more words on exactly what the problem was that you had with the door and what you did to get the door back remounted. And also, the payload people were wondering what the maximum temperature was that you saw on the PCG prior to getting the door remounted.
Okay, I'll answer the second part, and Dan can answer the first part. It was 4.2 when we finally got the door put back on again.
Roger that. Copy 4.2 degrees.
Okay, as far as the problem, it was just kind of the old locker type problem. The two top attach points are old type locker latches, and the bottom are unique to the rim. First we couldn't get the bottom started, so then we got those started. Then we couldn't get the top started. Just kind of seemed to be like the thing was torqued a little bit due to cabin changing shape. Ultimately, with just working at it a while, we finally got all the latches to catch and got it bolted down. And fortunately, we don't have to take it on and off a couple times a day.
Roger that, Dan. Sounds good. And that ought to clear up some of the questions that the payload people had. Appreciate it.
And when we got latched back down, it looked like it was fully seated from just looking at how the latches matched up. But we also took the mirror out of IFM and kind of went around the edge, and it looks like it's got a good seal to us.
Roger that, Dan.
In Houston, Columbia, we have 21 blank pages in the tags, if that's what you did to us.
Columbia, we think that's about the right count. We're planning on sending a test message up to you here at some point, but we've been having some difficulty in doing that. And we're also going to lose you here in about a minute and 10 seconds on the East Hedris, and we'll see you on the other side at about 5:41.
Okay, we'll see you there.
This is Mission Control Houston at mission elapsed time, 5 hours and 40 minutes. We're about 20 seconds away from acquiring signal again through the Tracking and Data Relay Satellite West. Currently aboard Columbia, Mission Specialist Dunbar in the final stages of the Remote Manipulator System checkout, a very thorough, detailed demonstration of all of the various manual and automatic and combination operational modes of the RMS, assuring its readiness to support the Flight Day 4 grapple and photo survey and berthing operations. We're now beginning to acquire signal through the western satellite and should be taking some air-to-ground comm shortly. This is Mission Control Houston taking live television from Payload Bay camera of Columbia. Looks like camera B, a black and white camera that's looking directly into the end effector of Columbia's remote manipulator system.
Columbia, Houston on Hedris West.
We're with you, Houston, and I've got a few words on the RMS.
Okay, go ahead, Bonnie.
Okay, we're at page 3-11, step 10, and when we took the RMS select to off and the power to backup, almost simultaneously we had several SM messages for PDRS slip on all joints, butt, shoulder, yaw, and for all. There was also an RMS master alarm.
Roger that. We copy, we see the same messages down here, and we're looking at it, Bonnie.
Okay, and I just want to verify you copied that occurred simultaneously with taking select power to off.
Roger that. We copy. We'll be back momentarily with some words for you.
Okay.
Columbia, for Bonnie, you can go ahead and ignore those messages. We're going to continue to look as to what the cause was, but you can go ahead and continue to press through the RMS checkout procedures.
Okay, and we'll do that.
This is Mission Control Houston. In spite of the PDRS slip or RMS fault messages encountered when Dunbar commanded the RMS selector off, flight controllers here on the ground looking at telemetry and the RMS systems are assured that the RMS is in good shape and that there are no problems. And while we investigate here on the ground the probable causes for those spurious messages, Dunbar was asked to press on in the RMS checkout. This live view currently coming from camera Bravo on the payload bay of Columbia is an extreme close-up looking directly into the end effector of the robot arm. That motion of the mechanism inside the end effector there is indication that Dunbar is continuing in the RMS checkout, showing the wire snares inside the end effector, which are used to close around grapple fixtures returning to their grooves or to the stow position.
Houston, Columbia.
Go ahead, Columbia.
We're complete with the RMS checkout, and just want to know whether you needed some direct drive data or if you had it down there.
Columbia, Bonnie, we've got everything we need.
Okay, everything looked good up here.
It's looking great down here. We've been watching the end effector on the TV, and we're getting great video.
Super. I'm ready to go into power down.
Roger that. You've got to go ahead and press on with RMS power down. Columbia, Houston.
Go ahead, Houston.
And David, we're seeing the temperature on camera B that you've got selected above the limit where you should have already gotten the alarm. I'd like you to go ahead and power off camera Bravo and cycle through the other cameras to check the temperatures and power off any camera that's above 45 degrees.
Okay, Steve, that can work.
This is Mission Control Houston at Mission Labs time, 5 hours, 50 minutes. The checkout of the remote manipulator system is complete. All systems proved out very well, with the exception of some unexpected but false fault messages which registered when the RMS selector was commanded off. There have been no unexpecteds or anomalies involved in the checkout at all. The RMS appears to be very healthy and ready to support Flight Day 4 activities. Currently in progress is the RMS power down procedures put in work by Mission Specialist Bonnie Dunbar. In addition to that, the instrumentation and communications officer here in the flight control room has been tracking a number of camera temperature problems. Various television cameras in the payload bay of Columbia have been showing some temperature fluctuations, and those in use showing some high normal temperatures. Nothing in the danger range, nothing that would cause damage to the cameras, but enough to want to keep a watchful eye on those cameras, and that information was provided to the crew, who was asked to help keep an eye on those cameras too and cycle any off that began to reach the upper normal limits. Columbia now on the ascending node of its 5th orbit of this shuttle mission STS-32, chasing LDEF, which is currently on orbit number 2,376. Correction, dropped 30,000 off that number. That's orbit number 32,376. And we're taking live television again from the payload bay of the orbiter Columbia. This is Mission Control Houston. This live scene from the Alpha camera in the forward port location of the payload bay aboard Columbia, looking aft along the longeron at the MPM, or manipulator positioning mechanism, for the elbow, as Mission Specialist Dunbar drives the robot arm into the stow position, or into the berth position. There are 3 MPMs, or positioning mechanisms, along the port longeron, upon which the RMS is cradled. One in the upper arm location, one below the elbow on the lower arm, which is the one in the foreground of this view, and then one further out at the wrist joint, which is in the center of the frame.
Columbia, Houston, your Spec 76 comm message is another camera over temp, and if you could check it and power that camera down, please.
done that. We have both cameras B and C off.
Roger that. B and C off.
Houston, Columbia.
Go ahead, Bonnie.
RMS power down's complete.
Roger, we concur. Nice job.
Thank you. It's a beautiful looking piece of hardware.
Roger, looks good from here.
This is Mission Control. At mission elapsed time, 6 hours and 18 minutes. We're continuing to take some intermittent live television from the payload bay cameras of Columbia. And when we do have downlink views visible in the field of view is the remote manipulator system, the robot arm, cradled in its berth, and having been fully checked out and verified, ready to support Flight Day 4 RMS operations.
Houston from Marcia.
How about we take a message?
That'd be fine. If you could pass to Marcia that we'd like to delay the CNCR ops until sunrise, and it should be at an MET of around 7:35.
CNCR to sunrise about 7:35. Got it.
This is Mission Control Houston. That last exchange between Commander Dan Brandenstein and Capcom Stephen Oswald regarding the CNCR, or characterization of neurospora circadian rhythms experiment, which is a study of bread molds and their diurnal cycles, or their natural biological cycles as affected by day-night cycles. And one of the constraints on beginning the experiment is that they conduct the operations of setting it up during a daylight period, and they asked him to pass along to Mission Specialist Marcia Ivins, who obviously has her hands full with a number of other secondary experiments in the middeck today, that she would need to delay the start time of the CNCR. This is Mission Control Houston.
Columbia, Houston, we've got the NPC burn pad for you when you're ready to copy it.
Okay, Houston, stand by 1 second. Yeah, Houston will be a little bit more in a second. We just want to finish up the app RHD checkout, then I'll get back to you.
Okay, that'll be fine.
This is Mission Control Houston. NASA Select is now momentarily originating from the Johnson Space Center on SATCOM F2R. After the live television views we've been taking from Columbia, we'll have a few minutes broadcasting on the satellite before we turn the satellite over to the Kennedy Space Center to bring in some launch video replays for the research and analysis folks here at JSC. Coming up in about 43 minutes is the NPC burn, which is a plane change maneuver in a lateral direction that's designed to alter the orbital plane of Columbia to place it in the what's called the phantom plane, or the plane that LDEF is expected to be in at the time of a rendezvous. That burn is going to be a very small burn, not a less than a 3 foot per second burn, and as such, the reaction control system thrusters will be used to conduct the burn. And we're standing by to reinitiate discussion with the flight crew aboard Columbia and give them all the details on that NPC burn. During the last downlink television we had, we saw the final stages of the RMS checkout as Mission Specialist Dunbar placed the arm back in the cradle after having proven successfully all of the manual and automatic and manual augmented control modes on the RMS, proving it ready for Flight Day 4 rendezvous activities. Our next shuttle television consists of launch replays from the Kennedy Space Center upcoming in just about a minute. These replays will be originating from the Kennedy Space Center in Florida. And at 6 hours and 40 minutes into the flight of Columbia on shuttle mission STS-32, this is Mission Control.
Houston, Columbia, we're ready to copy a pad.
After that, Dan, it'll be an RCS select burn. We'll be using plus X. TV roll is all balls. Ohms trim loads are NA. Weight is 244,505. TIG is day 0, slant 07 hours, colon 22, colon 18.3. Peg 7 targets, Delta VX plus all balls. Delta VY plus 002.2. And Delta VZ is plus all balls. Maneuver attitude, roll 036, pitch 120, yaw 345. Delta V total is 002.2. TGO 00:09er. VGO X is plus 002.14. VGO Y is all balls. VGO Z is plus 000.42. Target HA 194. HP plus 156. Ohms gimbal check is NA. RCS interconnect, right ohms to RCS. Down mode options are none. And ohms helium reg test is NA. IMU deselect NA. And read back when you're ready.
Okay, we got our RCS plus X burned. TV roll 000. Trim load is NA. Weight 244,505. TIG at 0 days, 7 hours, 22 minutes, and 18.3 seconds. The Peg 7 targets, Delta VX is 0. Delta VY is plus 2.2. And Z is 0. The attitude is 036, 120, 345. Delta V total is 2.2 with a TGO of 9 seconds. VGO in X plus 2.14. Y is 0. Z is plus 0.42. Our orbit will be a 194 by 156. There's no gimbal check. There's a right ohms to RCS interconnect. There's no down mode and nothing else.
After that, Columbia, you got it all. And one other item, we've been having difficulty in getting a tags test message up to you. We've worked it down here, and we don't seem to be able to find any problems on the ground, so we're working on some troubleshooting procedures for you. We should have those in the next 20 minutes or so.
Okay.
Columbia, Houston, I'd like you to check a switch for us on A8 Lima.
Ready to copy.
I'd like you to check the port RMS heater configuration. We think it should be A auto and Bravo off.
We'll check in a second.
Hey, Columbia, we're talking about it here for just a second. Be right back to you. Columbia, Houston, we'd like you to go ahead and configure the port RMS heater, please. A auto and B off.
Okay, that's complete.
Columbia, Houston, we just sent you an update for the orbiter state vector.
Okay, thanks.
This is Mission Control Houston. NASA Select is again originating from the Johnson Space Center on SATCOM F2R. Flight controllers here in Houston and crew aboard Columbia preparing for a plane change maneuver. One of the first of a few plane change maneuvers that will be necessary to place Columbia in the orbital plane of LDEF. That burn coming up in about 14.5 minutes. This burn is an out-of-plane burn, which essentially maneuvers the orbiter in the y-axis, much like changing lanes on the freeway, moving laterally.
Houston, we've got about a minute and a half till we lose you on the East Tidris. We'll be picking you up on the west side at about 7:19, and you'll be talking with Jim when you come out the other side.
Okay, sounds good. We'll see you there.
That plane change burn is scheduled to occur at mission elapsed time of 7 hours, 22 minutes, and 18 seconds. Total change of velocity in the y-axis will be 2.2 feet per second. That will be the total delta V, all in the y-axis. And the resulting orbit will not change in terms of apogee and perigee. There will be no altitude adjusts in this particular maneuver. It'll remain at roughly 194 by 156 nautical mile orbit, but using the reaction control system thrusters will essentially move in a lateral position, much like changing lanes on the freeway, to reach or acquire a orbital plane for Columbia that more closely resembles that which is predicted for LDEF on the time of rendezvous on flight day 4. And we're just now passing out of the range of the tracking and data relay satellite east, due to acquire signal again in just about 9 minutes through the western satellite. On board Columbia, mission specialists busily going to work with the secondary payloads, mid-deck experiments, including the fluid experiments apparatus. The specific experiment using that FEA hardware is the microgravity disturbances experiment, for which mission specialist Bonnie Dunbar is also a co-principal investigator. The FEA set up the PCG-1 and PCG-2 activation, as well as preparations for the CNCR operations, which are due to begin here in about 25 minutes. Have managed to keep the mission specialist team quite busy as crew commander Dan Brandenstein and crew pilot Jim Weatherby prepare to perform this plane change maneuver in about 11 minutes. One anomaly that has come up in the last couple of orbits and has been discussed here in the flight control room, and for which some potential in-flight maintenance procedures are being developed for use by the flight crew. The flight controller here in Houston, the instrumentation and communications officer, whose job it is to command the text and graphic system on board the vehicle on and off, and to send test signals and messages, as well as command imaging on board the vehicle, has noted that the tags has not been accepting, actually not been receiving test messages sent from the ground. All the ground-based hardware and systems have been checked out and found to be fault-free, and there's some discussion at this point of some possible in-flight maintenance to check one of the connectors on the text and graphics system on board the vehicle. But other than that, Columbia is a very clean machine. Flight controllers and flight crew stepping very methodically through the planned timeline today with very few changes. The RMS checkout was completed successfully today, proving out the remote manipulator system, or the robot arm's readiness for Flight Day 4 grapple, photo survey, and berthing operations. So all in all, a very successful and event-free day. Again, we're just about 9 minutes away from the first plane change maneuver, and about 6 minutes from acquiring signal again through the tracking and data relay satellite west. 7 hours and 13 minutes into the flight of Columbia on shuttle mission STS-32. This is Mission Control.
Columbia, Houston, back with you on the west satellite.
Houston, we're just about ready to burn.
This is Mission Control Houston. We're experiencing intermittent data and voice dropouts in our contact with the crew of Columbia through the tracking and data relay satellite west. We're standing by for relock of signal to verify the burn, which should have been accomplished by now.
Columbia, Houston, we'd lost data for a couple of minutes. We're back with you now.
Okay, well then you probably missed the burn, but it went just fine, and we're maneuvering back to our attitude.
Okay, that sounds good, and you're right, we did miss the burn.
Okay, I guess we goofed, didn't record all the rates, but the biggest was 0.14, and that was an accident.
Okay, we copied. Thanks, Dan.
This is Mission Control Houston at mission elapsed time, 7 hours and 27 minutes. We have completed the first plane change maneuver. The NPC burn went off on time as expected, and although flight controllers here in Houston did not have the advantage of watching that data live due to some comm dropouts through the tracking and data relay satellite, the result of the burn looks very good, as reported by the ground controllers here in Houston, and the burn went without event, as reported by Commander Brandon Stein aboard Columbia.
Houston, Columbia.
Go ahead, Columbia.
Yeah, as we're looking ahead to this IMU line, do you think that'll be required or not?
Yeah, Jim, we're going to need to do that because of the COAS cal. We do have a different time for you. If you're ready to copy, I'll give you that information.
Okay, stand by. We were hoping it'd be a different time. Okay, Jim, go ahead.
Okay, Wakesby, the maneuver will still be at sunset, but that MET is now 8:29. We want you to perform the IMU align with attitude set alpha 2. And for your -Z COAS cal, your attitude will be roll 067, pitch 082, and yaw 009er with A auto vern. Star ID is -Z is star 21. The star will be available at 8:24 until 9:07. And you should be in a fine attitude when you're in that the -Z COAS cal one, and for no sun on the payload, and so you shouldn't have to worry about maneuvering back anytime soon.
Copy, stand by. And Houston, let me read that back if you're ready.
We're ready, go ahead.
Okay, we'll do an IMU align. We'll maneuver at 8:29, and we'll use star alpha 2, star pair alpha 2,
When we do the minus E COAS, we'll maneuver to roll 067, pitch 082, and yaw 009er. We'll do the cow in A auto burn. Or is that what you wanted us to maneuver in A auto burn? And in the minus Z, will you start 21? And that's available 824 through 907.
That's a good copy, and yeah, we wanted you to initiate the track in A auto burn to maneuver.
Okay, we got it, thanks.
This is Mission Control Houston. That last exchange between pilot Jim Weatherby and Capcom Jim Voss was regarding the upcoming scheduled maneuver to align the inertial measurement units on board Columbia in order to maintain the most accurate navigational platform on board Columbia in preparation for rendezvous in a few days. Following this most recent plane change maneuver, it's very desirable to realign the inertial measurement units on board that provide inertial and reference information to the navigation base. After a small RCS burn to maneuver the vehicle into the proper attitude, the crew will align the inertial measurement units and then calibrate the crew optical alignment site, which could become a key mechanism for the crew in the final stages of rendezvous on flight day 4.
Columbia, Houston, we have a circuit breaker on R15 we'd like for you to check when you can.
Okay, we're ready.
Okay, on panel R15, row Charlie, main Bravo, KU antenna heater. I'd like for you to check that and see if it's in or out. And the reason is we've been seeing low temperatures on the KU band antenna.
The antenna heater circuit breaker is in.
Okay, Wixby, thanks.
This is Mission Control Houston. That last request for crew aboard Columbia to check the circuit breaker controlling the KU antenna heater was in response to readings here on the ground that showed the temperature on that heater being slightly lower than normal. And the response from pilot Jim Weatherby was that that circuit breaker was in the in position, which indicates that it's functioning normally and is probably not the culprit in the lower temperature reading than expected.
Columbia, Houston, we have a tags troubleshooting procedure when you're ready.
Okay, Houston, is this a write-down procedure, or is this a stand in front and do as you say procedure?
I expect you better write it down.
Okay, stand by a second then.
Well, Dan, if you want to, you can just stand in front of it and we'll talk you through it. It's not that hard.
Okay, now we got the paper and pen in hand now. We'll take it up front and then we'll try it and we can talk about it later.
Okay. First thing you want to do is verify that the tag's power light is off. Then open the tag's volume access door in AVBay 3 Bravo. Then looking on top of the tags, locate connector Juliet 2, which is the middle connector. Want to check that connector for tightness and report the condition to the MCC. If it is tight, we want you to continue with the procedure. If it's loose, we'd like for you to tighten it and then check back with us. If you find that it's tight, we'd like for you to demate the connector from J2. Check the condition of the pins and sockets. Let us know what you find. And then remate the connector. and let us know when you're done. Hopefully, by checking this electrical connector, we'll get the power back to the tags machine and it's going to work for us.
Okay, Houston, we'll give it a whirl.
Columbia, Houston for Dan.
Go ahead.
Now, since we had to move the maneuver for the IMU line, we're wondering if you'd like to go ahead and do your PMC before you do that, since we have a little bit of time, or do you want to wait until after your IMU align and COASCAL to do the PMC?
We'll wait till after, Jim.
Okay, we'll talk to you about it after you're done then. Just let us know when you're ready. Also, I have one thing for your pre-sleep cryo config when you're ready for that.
Ready to copy.
Okay, after you've completed your pre-sleep fuel cell purge, on panel R1, O2 and H2, tank 2 heaters, Alpha and Bravo, all 4 of them off, and O2, H2, manifold valve, tank 1, 2 of them closed, talkback closed, and there will be no pre-sleep water dump required.
Okay, stand by.
Go ahead, Dan.
Okay, I went through and did what you asked. It was tight when I checked it out, so I disconnected it. Looked at both the pins and the connector. The pins were all straight and looked in good shape. The connector, the only comment I had on that, looking up the holes in the connector, it looks like there's only 4 out of the 6 that have contacts, up inside the connector, but that's probably not unusual. I don't know. And I reattached it, so that's about all you had for me to do.
Okay, Dan, and that's the correct number of pins in that connector. We'll take a look now and see if we fixed it.
Okay, I didn't go back through and do any of the switch throws, like redo the tags enable in the orbit ops checklist or anything.
Okay, stand by, Dan.
And Houston, if you still have that other flight note, I'll read it back when you're ready.
Okay, Jim, you can go ahead with that now.
Okay, in the pre-sleep activities after the fuel cell purge, we'll configure O2 and H2 tank 2, Alpha and Bravo, all 4 to close. And O2 and H2 manifold tank 1, manifold valve tank 1, 2 of them to close, and there'll be no pre-sleep water dump.
Roger, just on the tank heaters, those are off, not closed, but good readback.
Yeah, okay, thanks.
Columbia, Houston referenced the tags troubleshooting. No further action is required right now. We'll let you know later if it solved the problem.
We copy.
This is Mission Control Houston. In order to verify that the text and graphics system troubleshooting procedures performed by Commander Brandenstein did the trick, we're going to have to wait until we've handed over from the tracking and data relay satellite west to the eastern satellite and see if we can try to uplink another page or 2. And until then, we won't know. Crew currently getting into their pre-sleep period on board Columbia and beginning to wrap up their busy day on the middeck of unstowing and setting up their laboratory, in which they'll be conducting observations, activations, deactivations, and experimentation with a number of middeck experiments. The fluid experiments apparatus supporting the MDE experiment, the American Flight Echocardiogram experiment, the bread mold experiment, and 2 crystal growth experiments. After encountering a little difficulty in closing the door on the PCG2, which is the crystal growth experiment that will be subjected to colder temperatures, approximately 4 degrees centigrade, a little bit of elbow grease and perseverance by the crew did the trick there and got that door closed. And both crystal growth experiments are activated and operating. Deleted from the pre-sleep activities tonight is water dump. There's plenty of space left in the supply and the waste tanks, and there'll be no need for that tonight. After a fuel cell purge, a private medical conference, as is standard for flight days 1 and 2 for shuttle missions, and the IMU alignment and COAS calibration, the crew of Columbia will be headed for a sleep shift along with the Orbit 2 team.
Columbia, Houston, we'd lost you for a while, but we're back now. Columbia, Houston, we dropped out again, but we're back with you now.
This time I noticed it.
This is Mission Control Houston. At mission elapsed time, 8 hours and 24 minutes. Crew aboard Columbia currently wading into their pre-sleep timeline. This color graphic currently on NASA Select television is provided to the control center and our television controllers by the Mission Operations Systems Laboratory. This is a display that's driven real-time by telemetry and tracking data that accurately depicts the location of the orbiter as well as the LDEF over the Earth and along their orbital path. The attitude of Columbia at this point is payload bay towards the Earth, as is evidenced by the black tiles of the underside of the orbiter showing up towards the screen. And as Columbia orbits in a 193 by 155 nautical mile orbit, the 3 somewhat horizontal lines depict the orbit of Columbia, the orbit of LDEF, which is the small grayish-white dot in a adjacent orbit just ahead of Columbia, and as well as the equator. The broken ellipses that appear across the face of the globe are the same ellipses that appear on the Mercator tracking map in the front of the control room. Those represent the range of the ground tracking stations that are located around the Earth that support shuttle operations. And as the sun sets on the continent of South America, Columbia just about to cross the terminator itself from light into dark as it continues to chase down a long-duration exposure facility represented in the adjacent orbit, and this excellent graphic provided by the Mission Operations Systems Lab. This is Mission Control Houston. Guidance Nav and Control Officer here in the flight control room confirms that crew aboard Columbia maneuvering the vehicle to the IMU alignment attitude at this time. This is Mission Control Houston. We're again having a look at the orbital track graphic provided by the Mission Operations Systems Laboratory, depicting Space Shuttle Columbia as it pursues LDEF and its orbit around the Earth. LDEF being represented by the small gray and white object on the far right-hand side of the frame as Columbia and LDEF track in sequence over the southern tip of the African continent.
Columbia, Houston, we see a good align. We don't need any numbers from you. Just a couple of words before we go LOS. There was no joy on the tags, so we'll be teleprinting up your morning mail tomorrow. An explanation on the high and low manifold pressures that you saw earlier during an LOS. It appears that there were some jets that were firing at the time, and it just caught some of the update rates high and some low, and so there was no problem there. We'll be back with you at 8:57, and if you could, we would appreciate a secondary status at that time.
Okay, they're still working on those, and we'll, sorry to hear about tags. Maybe we'll get inspired somewhere along the line, or it'll respond, and we're in the process of heading over towards the COAS Cal. Thanks.
Okay, and we'll have some folks in tonight working on the tags, and we'll see if we can come up with a different troubleshooting procedure for you by tomorrow.
Okay, thanks. And Jim, thanks for the words on the manifolds. Appreciate it.
Okay, and we'll have UHF for a couple more minutes also.
This is Mission Control Houston. We're currently out of range of the tracking and data relay satellite system. We'll acquire signal again through the western satellite in just a few minutes. Here in the flight control room, flight controllers are beginning to pull together their end-of-the-day messages, including some heads up to the crew that'll alert them to some flight plan updates that'll be in the works during the planning shift tonight for tomorrow's timeline. Other than that, expected air-to-ground dialogue between crew and flight controllers expected to be minimal through the end of the pre-sleep activity. We are expecting to get a brief report on the progress of activating a number of mid-deck experiments. We haven't had any significant problems reported with the mid-decks, minor door closure and hinge problems which were fixed. The only unresolved anomaly at this point is some problems with the text and graphics systems. Other than that, a very clean vehicle, working very well. No significant anomalies being chased by the flight control team, and not a significant amount of action left to the planning team when they show up here in about an hour. And we're just about 40 minutes away from putting the crew of Columbia to bed. After a very busy and highly successful first day on orbit, which saw a extremely accurate ascent to orbit, placing Columbia in a much closer than expected orbital plane to that we expect to find LDEF in on flight day 4. In addition, successful checkout verification of the reaction control or the remote manipulator system was conducted, showing that the robot arm is in good shape to support flight day 4 grapple, photo survey, and berthing operations. A number of the mid-deck experiments have already been unstowed, set up, and activated, and have been under the watchful care of the mission specialists aboard Columbia. After the very minor plane change maneuver that was done by the crew commander and pilot, a maneuver to an IMU align attitude followed by alignment of the inertial measurement units and a COAS calibration have been accomplished. And with that, all the major activities of the day have been squared away and put behind us. Yet to come is the standard Flight Day 1 private medical conference and completion of the fuel cell purge and other pre-sleep activities. Again, just about 35 minutes away from putting the crew to bed. At mission elapsed time 8 hours 53 minutes. This is Mission Control.
Columbia, Houston, we're back with you on the west satellite.
And you're loud and clear.
And we hear you loud and clear.
And Jim, we did, well, let's see, you already saw the IMU line. Dan did a COAS cal, and we have numbers for that if you need them. And we're maneuvering back to 23270.
Okay, we copied that, and we'll let you know if we need any numbers. Columbia, Houston, Wixby, we're just going to play back to get all the numbers, so we don't need those from you right now. Thank you.
Okay.
Columbia, Houston. Columbia, Houston.
Go ahead.
Yeah, we're ready for your PMC. If you'll just give us a time, then we'll configure for that time. Also, we're standing by for a secondary status if you're ready to give it to us.
We copied, standby.
Houston, Columbia.
Go ahead, Columbia.
Just a brief secondary status. PCG 1 and 2 are both complete. We're in the middle of CNCR, towards the end of the FEA setup, and we are going to try to configure AFE before we go to bed. We think we'd be ready for your PMC probably in about 10 minutes.
Okay, that sounds good. And we'll configure the PMC and we'll let you know when we're ready in about 10 minutes.
Okay, we'll see you then. Houston, Columbia.
Go ahead, Columbia.
Yeah, for the CNCR folks, we got everything back in the locker before dawn.
Okay, thank you. And could you clarify about FEA? You said you had it configured, is that correct?
Yes, it's all set up and ready to go. We're just sharing some hardware, and we'll be powering it up here shortly.
Okay, thank you.
Houston, Columbia for the middeck.
Go ahead, Columbia.
Okay, the PCG2 activation was completed okay, and taking pictures of them, that all went well. In tray 2, the drop in H15 had a noticeably smaller drop than the others, and we took a picture of it, and we took some camcorder of it, and if it looks good, maybe we'll send you that tomorrow. Other than that, it all went well.
Okay, we copied that. Thanks, and we look forward to seeing the camcorder shots.
Okay, and for CNCR, we finished the red package, and we're waiting for daylight to get all the way here. It looks like the bread mold lived on board while we didn't launch one day because every one of the tubes had about 1.5 growth fronts in it. We called them all normal, if the PI is listening, and we took some pictures and some camcorder of that too, and we did all the gas sampling. And then I forgot to tell you, for PCG, we did do all the cranks 8 times on all 6 trays. I didn't have a microcassette out, so I couldn't say that, so I'm telling you now.
Okay, thanks. What about your DSO 472? Any words on that one?
The word is 472 is complete.
Okay, thanks, Marcia.
Okay, Houston, we copy. Panels in command.
Thanks.
And in addition to the status report on that DSO, it was reported that all of the Flight Day 1 secondary activities are either complete or very near complete, with CNCR partially stowed PCGs 1 and 2 in place, and will be given time for protein crystals to begin to form in those canisters. The fluid experiment apparatus is set up, and the MDE experiment nearly configured. And with the flight echocardiograph yet to be configured, but with plans to set that up before going to sleep. Our next shuttle television is scheduled to be a live downlink from the payload bay of Columbia, upcoming on orbit 7. We expect to take that downlink television about 12 minutes from now at 4:05 p.m. Central Time. This television will be controlled from the ground by the instrumentation and communications officer here in the flight control room. Mission Specialist Bonnie Dunbar confirming that the panel was in command, allowing the crew, the ground, the opportunity to command the onboard TV system. And we're taking some...
We're configured for the PMC, so the flight surgeon will be contacting you for that conference.
And as we take live television from Columbia, the crew's been given a go to begin their private medical conference, which is a standard exchange on flight day 1 between the crew flight surgeon here on the ground and members of the crew. This aft-looking view from the Delta camera, a black or a color wide-angle lens, showing CENTCOM in its place in the aft end of the payload bay, and tilting up as Columbia tracks high above the Pacific Ocean, just beginning to pass into range of the Hawaiian Islands.
Columbia, Houston.
Hi there, we're back with you.
Yeah, glad to hear you again. Dan, we wanted one clarification before we tell you good night, and that was on your FEA and AFE. What I heard was FEA is configured and ready to go, and that you were going to have AFE set up before you go to bed tonight.
Yeah, this is Bonnie. We spent some time getting FEA set up and the cables all routed and so forth, and I'm just about ready to load the floppy, and that'll be done fairly shortly. And we'll have to do the same with AFE. It's just been a question of time and getting the cabling, routing, and everything put away.
Okay, that sounds real fine. And we'll be teleprinting up your morning mail to you, and we'll try not to bother you anymore. Your Orbit 2 team will be turning it over to the planning guys to look after you while you're sleeping tonight. So we'll see you tomorrow.
Okay, just let me give you a little rundown of, we're getting everything done. I guess there's a little more zero-gravity overhead than you kind of run into when you do it over in Building 9 and stuff. So we're going to probably run a little bit late tonight, but we're going to get everything up to speed and stuff before we stack out. So. Which also means we'll probably be a little bit behind schedule on some of the pre-sleep activities.
Okay, Dan, we understand, and we'll not bother you anymore.
Okay.
This is Mission Control Houston at mission elapsed time, 9 hours and 34 minutes. We're now officially into the crew sleep period. In actuality, the crew aboard Columbia just putting the finishing touches on what has been a tremendous day's effort, which finds Columbia in a exceptional position from which to continue chasing down LDEF and conduct a rendezvous on flight day 4 of this flight. We've seen the successful checkout verification of the remote manipulator system today. All systems aboard Columbia very clean, working well. We did experience a loss of one S-band FM system for which there is a redundant pair, and the redundant system is working very well, no impact there, with the exception of verification of some troubleshooting that was done this afternoon with the text and graphics systems. There really are no unknowns at this point, and the only significant planning actions for the oncoming planning shift beginning to arrive here in the flight control room is that of just minor tweaks and readjustments for the Flight Day 2 timeline, which in fact will be highlighted by the deployment of the CENTCOM satellite. As of last report, all the secondary experiments which were scheduled to be unstowed, set up, and activated today are in place and configured.
You don't have to answer if you don't want, but I'm going to do KU band antenna cable positioning now.
Okay, we copied.
And the American Flight Echocardiograph experiment is on its way to being configured prior to crew going to bed, and pilot Jim Weatherby calling down one last housekeeping chore, and that's repositioning the KU band antenna cable. The crew sleep period, beginning officially a few minutes ago, is scheduled to give the crew about 7 to 7.5 hours of sleep, and followed by a post-sleep period during which they'll have the chance to get up, do a little housekeeping, prepare a meal, and get themselves, the vehicle, and a CENTCOM ready for deploy. The first of a few minor plane change burns was conducted today. Those a series of burns over the next couple of days, including phasing burns, which will increase the closure rate of Columbia on the target, the LDEF, and plane change maneuvers, which are designed to, at key points in the next few days, make minor adjustments to the orbital plane of the orbiter vehicle, placing it more closely in alignment with the predicted plane of the LDEF in orbit on Flight Day 4. That NPC burn was a small burn, an RCS jet burn that resulted in a delta velocity of 2.2 feet per second. That burn went on time and was very nominal. The next major burn in the pursuit of LDEF will be a phasing burn early on Flight Day 2 tomorrow morning, which will involve a height adjust maneuver to accelerate the closure rate between Columbia and LDEF. So after a fairly quiet first day on orbit and a quiet day here in the control room, all indications are that there will be a very quiet planning shift at work here in the control room tonight. Columbia currently at an altitude of 190.4 nautical miles out over the South Pacific Ocean, with current orbital apogee of 193.7 nautical miles and a perigee of 155.9 nautical miles. Orbital period is 1 hour, 31 minutes, and 9 seconds. Columbia beginning the descending node of orbit 7. 9 hours and 40 minutes into the flight of Columbia on shuttle mission STS-32. This is Mission Control. Our next television event on NASA Select is scheduled to be a replay of Payload Bay television that came down on orbit 7. That replay is scheduled to begin in just a couple of minutes at 4:17 p.m. Central Standard Time. Again, this next television event is a replay on satellite of some Payload Bay views that were downlinked live from the orbiter Columbia on this orbit just a little while ago. It consists essentially of a cycling of all of the Payload Bay cameras as the instrumentation and communications officer here in the flight control room queried each of those cameras, checking them for proper operating status and checking to make sure that they're operating in the proper temperature range.
Houston, Columbia.
Go ahead, Columbia.
Just a final update on the CNCR. We finished marking the clear tubes, and it looks like They all have about 5/8 to 3/4 of an inch of growth on them if you want to pass that on to the PI.
Okay, about 5/8 to 3/4 of an inch of growth. Thanks.
Okay.
And one other thing, did you get your teleprinter message today?
We got one today. Did you send another one?
No, that was all just a test message. Wanted to make sure you'd gotten it.
We got it.
Okay, and we'll try to send you up your traj message in just a little while as soon as we get it done.
Okay.
Columbia, Houston, I guess we lied to you. One last thing, your traj message is coming up to you real soon on the teleprinter, and don't forget your LiO canister changeout.
Okay, thanks a lot, and Dan is getting ready to do that right now.
Roger, see you tomorrow.
Night, night. This is Mission Control Houston. Columbia now out of range of the Tracking and Data Relay Satellite East, waiting for acquisition of signal through the Western satellite in about 3.5 minutes. The planning team now on console here in Mission Control. Our next television event will be a change of shift briefing with off-going Orbit 2 Flight Director Bill Reeves. That briefing will occur at 5:15 p.m. Central Standard Time in Building 2, Room 135 here at the Johnson Space Center. This is Mission Control Houston at 11 hours 10 minutes mission elapsed time into the flight of Columbia and STS-32. Columbia now passing on the descending node of Orbit 8 after just crossing the equator. Columbia is now chasing the long-duration exposure facility behind it by about 1,230 nautical miles, closing on the satellite at a rate of 52 nautical miles per orbit. Now 6 hours and 18 minutes away. Crew spent a rather busy day activating some of the secondary payloads on the middeck of the orbiter, including the protein crystal growth experiment. And the characterization of neurospore circadian rhythm, CNCR. Once the crew wakes up later tonight or tomorrow morning, they will begin preparations to deploy one of the major payloads on this flight, and that is the CENTCOM Navy Synchronous Communication Satellite. The CENTCOM 4F5 is the fifth in the series of Navy satellites developed and built to provide worldwide communications between aircraft, ships, submarines, and land-based stations for the military services. The actual deploy of the CENTCOM is now scheduled for 1 day, 0 hours, 44 minutes mission elapsed time. That translates to 7:19 a.m. Central Standard Time. That will be followed by a separation burn of Columbia to maneuver away from the satellite, and that burn will actually cause Columbia to phase backward, and therefore will lead to an unseparation burn termed here in the control center, which will actually be the negative of the sep burn, which phases us away from LDEF. So the unsep burn will actually put us back where we were after the separation burn. That separation burn will occur about 15 minutes after deploy of the CENTCOM. Columbia is currently in a 194 by 156 nautical mile orbit, orbiting the Earth now every 1 hour 31 minutes. Though the crew sleep cycle has begun now about 1 hour and 50 minutes ago, they more than likely are still awake, possibly taking photographs. with some of the free time they have between now and falling asleep. Comfort factors aboard Columbia right now, the temperature is about 73.5 degrees with the humidity at a comfortable 37%. Earlier today, the crew activated the remote manipulator system, the RMS, the arm that will be used to grapple LDEF, rotate it for the photo survey, and then berth it in the payload bay. That arm will be commanded by Mission Specialist Bonnie Dunbar. And in preparation for that event on Flight Day 4, earlier today, the crew activated the payload retention latch assemblies, or PERLAs, used to secure LDEF in the payload bay once it is berthed after retrieval. As with each day and each handover between shifts here in the control center, the flight dynamics officer reports on what our next PLS would be, and that stands for primary landing site opportunity. That would be in the event that we were forced for some malfunction aboard the vehicle to come home. That would be our next opportunity to land at our primary landing site of Edwards Air Force Base. And our next PLS for tomorrow would be on orbit 18 at 1 day, 2 hours and 37 minutes mission elapsed time. That would be the time of ignition of the orbital maneuvering system engines. Landing would be approximately an hour later. And of course that's just in a contingency. Presently everything is going very smoothly aboard the orbiter. Very few, very minor problems to report. One with the text and graphics system, or tags, is used quite similarly like a fax machine, and that has malfunctioned and has not been able to be used since activation. The planning shift this evening will go through some troubleshooting procedures to try and determine what the problem is with that, and hopefully have some good words for the crew when they wake up early tomorrow morning. With the launch of Columbia in the morning rather than in the evening, the flight plan is a little off in some places, and I guess the major difference would be the difference in the sunrise and sunsets on each orbit, and they're off by about 40 minutes on the mission elapsed time. That of course will be corrected on the execute package, which is distributed shortly before crew wake up each day. At 11 hours 19 minutes mission elapsed time, this is Mission Control. This is Mission Control Houston. We're now about 5 minutes and 15 seconds away from losing signal with Columbia through the tracking and data relay satellite east. Columbia now beginning orbit 9. Chasing the long duration exposure facility, which has just begun orbit 32,380. NASA Select transmission will be interrupted for approximately 3 hours momentarily for other usage by the Landsat organization. When we return around 9:30 Central Standard Time with NASA Select, we will replay Flight Day 1 activities, including Columbia's launch earlier this morning. We're now about 5 hours and 30 minutes away from waking the crew to begin their Flight Day 2 activities, which will lead off with deployment of the CENTCOM communication satellite for the Navy. That deployment is scheduled for about 1 day, 0 hours, 44 minutes, or about 7:19 a.m. Central Standard Time. Now 11 hours, 58 minutes into the flight of Columbia on the mission of STS-32 to retrieve the Long Duration Exposure Facility. This is Mission Control Houston. This is Mission Control Houston. Our next television event will be a replay of Flight Day 1 activities. That replay will occur at a mission elapsed time of 14 hours 55 minutes or 9:30 Central Standard Time this evening. Columbia now passing out over the Pacific Ocean on orbit 9. Now just over 5 hours from waking the crew to begin their Flight Day 2 activities. Currently at 12 hours 28 minutes mission elapsed time. This is Mission Control. This is Mission Control Houston. Columbia now beginning orbit 10, passing over the east coast of Africa. Now about 4 hours and 3 minutes away from waking the crew to begin their Flight Day 2 activities. Once the crew does awake tomorrow morning, they will begin some further activities, continue activities on the mid-deck payloads and begin the pre-deploy checkouts and checklists of the Navy CENTCOM 4 satellite, which is scheduled to be deployed at 1 day 44 minutes into the mission. Once the protect attitude with a separation burn away from the satellite about 15 minutes later. Planning shift flight controllers here in the mission control room continue to prepare messages for uplink to the crew when they wake up. Included in those in that uplink package is changes to the flight plan, although there are only a few minor changes that will be seen on the flight plan tomorrow morning by the crew. Once the CENTCOM is deployed, Columbia will continue to be maneuvered throughout the coming days in its primary quest to retrieve the long duration exposure facility, which was placed in orbit in 1984. Columbia is now closing on the facility about 52 nautical miles per orbit, currently around 1,200 nautical miles behind LDEF. And that satellite is exhibited on the screen in the front of the Mission Control Center as a cylindrical. 29 minutes. This is Mission Control. This is Mission Control Houston. NASA Select now originating from the Johnson Space Center in Houston. Columbia now on the end of the ascending node of orbit 10, heading out into the Pacific Ocean. We're now about 3.5 hours away from waking the crew to begin their Flight Day 2 activities. Planning shift controllers continue to prepare messages for uplink to the crew on the teleprinter early this morning. Once the crew does wake up, they will perform their post-sleep activities, including breakfast and exercise. And they will also get into activation and continued work on some of the mid-deck experiments aboard Columbia for this flight. One of the major activities of the day will be the deployment of the CENTCOM communications satellite for the Navy. That will occur at about 1 day, 0 hours, 44 minutes mission elapsed time. That translates to about
7:19 a.m. Central Standard Time. After deployment, that satellite will be boosted to a geosynchronous orbit 22,300 miles above the Earth. It is the final satellite built for the Navy in this configuration. All 5 have been deployed by space shuttles. STS-32 is the first of a series of missions that will help to validate the orbiters, extending the duration of missions. This extended duration orbiter flight, or EDO, will help the crew and help medical people here at the center and around the country at other NASA centers help understand more of the physiological aspects and of the crew members for longer stays in space, hopefully leading to a better understanding of what life will be like on the space station in the later 90s. Later on flight day 4, which comes up on Friday morning, the crew of Columbia will close in on the long duration exposure facility, which is the other major activity scheduled for this flight, and that payload will be retrieved and returned to Earth for extensive study to look at the experiments, a number of 57, which are on board that free-flying satellite. And also we'll take a good hard look at the outside of the satellite to help determine how it has withstood almost 6 years in space. Will also help planners in the future in designing spacecraft and the space station for protecting it from the This is Mission Control Houston, end of the replay of Flight Day 1 activities. As back here in the control center, the planning shift team members are reviewing messages that will be uplinked to the crew prior to their wake up here in about 2 hours. Columbia now just acquiring signal through the tracking and data relay satellite west. All continuing to go very smoothly aboard the vehicle with all systems. And all very quiet here in the control center as all planning shift members put in their final inputs for uplink to the crew. The orbiter status has not changed. Columbia is still in a 194 by 156 nautical mile orbit, circling the Earth every 91 minutes. Traveling slightly ahead of Columbia on its orbit is the Long Duration Exposure Facility. Following deployment of the CENTCOM satellite tomorrow morning, the crew will perform a series of maneuvers and burns, putting it in close proximity to the LDEF. Giving mission specialist Bonnie Dunbar the capability and the reach with the remote manipulator system arm to grapple LDEF. That is scheduled to occur Friday morning, flight day 4. As Columbia travels on its 11th orbit, LDEF is now traveling on its 32,382nd orbit. We're now 15 hours and 26 minutes into the mission. This is Mission Control. This is Mission Control Houston, now about 35 minutes away from waking the crew to begin their Flight Day 2 activities. Orbit 1 team members are beginning to come into the control center to take handover from the planning shift. Columbia is currently on the ascending node of orbit 12. Right now, loss of signal through the tracking and data relay satellite west. We will pick up communications with the orbiter on the western satellite in just a couple of minutes from now. All messages put together by the planning team have been reviewed and are in the process of being uplinked to the crew. Controllers plan on attempting to use the text and graphics system during the evening. Troubleshooting procedure determined that the problem was on the ground and not with the unit on board the orbiter, and this will give us an opportunity this morning to see if that troubleshooting procedure has worked and if the tags can now be operational for this flight. This is Mission Control Houston. Our next television event is a change of shift briefing with off-going planning shift flight director Bob Castle. That is scheduled for 1 a.m. Central Standard Time on January 10th in Building 2, Room 135 here at the Johnson Space Center. Any news media interested in taking part in that briefing should notify the JSC newsroom at area code 713-483-5111. This is Mission Control Houston. Our next television event is a change of shift briefing with off-going planning shift flight director Bob Castle. That briefing is scheduled for 1 a.m. Central Standard Time, January 10th, in Building 2, Room 135 at the Johnson Space Center. Anyone interested in taking part in that briefing should notify the JSC newsroom at area code 713-483-5111.
Good morning, Columbia.
Good morning, Earth.
We thought you'd appreciate a little Bing Crosby to wake up to this morning.
It was wonderful. The other wonderful thing we noticed this morning is tags is working.
Well, that's good news. That was our first question. We wanted to see if you had gotten our messages this morning to see if we had to teleprinter up the rest.
Well, we haven't gotten them all read yet, but we do have a handful here that we're looking at.
Okay, you should have messages 1, 3, 4, 5, and 6. And message 1 was set up twice.
This is Mission Control Houston. The wake-up music title of the song was What's More American, and that version was sung by Bing Crosby. The reference to the tags by the crew was that the messages had gotten on board okay and looked good, and that's good news for the flight controllers here. Shows that the text and graphic system appears to be working nominally at this time.
And Houston, Columbia, I think we got all you called for. We got 1, 3, 4, 5, and 6.
Outstanding. We think we discovered our problem here on the ground, so sounds like the system is fixed, and we understand it's all readable.
Good.
And Columbia, just as a heads up, the first 45 minutes or so is not too busy, and it'll give you time to review your messages and get yourself set for the day. It's going to be a busy one.
Looks like it, thanks.
This is Mission Control Houston at mission elapsed time of 17 hours 36 minutes. Columbia now on orbit 12, descending node, now trailing LDEF by about 965 nautical miles, still closing on the satellite at 52 nautical miles per orbit. The crew just waking up and getting ready to get into a busy days of activities, including deploying the Navy synchronous communications satellite. That will occur a little bit later this morning at about 7:19 Central Standard Time, or 1 day, 0 hours, 44 minutes mission elapsed time. As Columbia completes its 12th orbit, LDEF will be completing its 32,383rd orbit. Our next television event, a change of shift briefing with off-going Flight Director Bob Castle planning team, has been canceled. That briefing had been scheduled for 1 a.m. However, that briefing now has been canceled.
This is Mission Control Houston at 18 hours 3 minutes mission elapsed time. The handover between the planning and Orbit 1 teams is complete. Planning team has been released for the night. The systems aboard Columbia are in very good shape. One example, the data processing systems officer during the handover briefing told Flight Director Al Pennington, if this were a card game, I'd pass. So there really is nothing to report from that system. Most other systems very clean. The propulsion systems officer reports all of our propulsion and consumables margins are in good shape. We're using fuel and juice as expected. Our NC2 burn will take place on the shift this morning in about 2.5 hours, and we'll give you some updated numbers on that maneuver as it comes along. The IMUs are in good shape aboard the Columbia. They did a compensation of 2 gyroscopes yesterday. They also did a COAS calibration, the COAS, the Crew Optical Alignment Sighter, and that's in good shape. So Columbia and her software and attitude systems are in good shape and know exactly where the vehicle is in time and space. The orbiter is in a 193 by 155 nautical mile orbit. The NPC burn we did yesterday had a change in velocity of only 2 feet per second, which tells you that the ascent was extremely good and on target. That puts Columbia 965 nautical miles behind the long-duration exposure facility and closing at 54 nautical miles per orbit. Today's NC2 burn will take place at 20 hours, 25 minutes, and 24 seconds mission elapsed time. The deploy of CENTCOM at 1 day, 0 hours, 43 minutes, and 51 seconds. As is common, the perigee kick motor burn that follows that deploy of CENTCOM, that burn will take place 45 minutes after deploy. The Columbia will execute a separation burn 15 minutes after deploy, or 30 minutes prior to the PKM burn. Later in the morning, at 1 day, 2 hours, 30 minutes, and 9 seconds, we will do an unsep burn, which is poor grammar but probably quite descriptive of exactly what we're doing. Whatever rates are introduced by the separation burn will be nullified relative to LDEF when we do the unsep burn. So if we burn and perform nominally at about a change of velocity of 18 feet per second, then we would reintroduce that in the opposite direction, another 18 feet per second, to keep us in the same relationship to LDEF, closing at the same rate. All of the continental United States landing sites look good for the next 2 days. Edwards has very good weather for at least the next 48 hours. Our control center and communications network systems all in good shape. The ECOM officer reports that there's nothing going on within his electrical and environmental systems. The cryo consumption is right on the predicted curve. The INCO officer reports we will be doing Detailed test objective 703 on revolutions 18, 19, and 20 this morning. Those are early handover tests between the two TDRS satellites. On orbit 18, we'll do an early handover from TDRS west to TDRS east of the S-band system only. And then on orbits 19 and 20, we will hand over on the KU system only early from the western satellite to the eastern satellite and then back. They are transmitting high data rate on S-band uplink, and that is a plan that we hope to keep in place for the duration of the flight. Otherwise, not a lot to report. The flight activities officer reports the crew sleep period will begin a half an hour later this evening and also tomorrow, which will get us on a system that will have us doing our handovers about an hour later each day than reflected in the pre-flight schedules, and we'll have those all worked out and printed up in our television schedule for the days to come. Beyond that, not much to report. The CENTCOM deploy coming up this morning at the tail end of the Orbit 1 shift. That'll be the big event of the day. We hope to take some television prior to that event at about 23 hours and 30 minutes mission elapsed time for the pre-deploy checkout activities. We hope to take television from the payload bay and perhaps even from inside the cabin of Columbia. Other than that, not much to report. Also a reminder, our change of shift briefing with off-going Flight Director Bob Castle has been canceled. Next opportunity to get a live flight director will be tomorrow morning with off-going Flight Director Al Pennington. At 18 hours, 9 minutes mission elapsed time, this is Mission Control, Houston.
Columbia, Houston, good morning.
Good morning.
Yeah, WEX, we see star 88 in slot 1 and star 26 in slot 3. The data looks good, and you're go for the align.
Roger, go for the align. And Houston, I'm sure you saw the alignment is complete.
Columbia, we copy, and we see a good alignment. And Columbia, the maneuver to IMU align attitude that was moved to 1905 in your flight plan update is now no longer required.
Okay, we copy that, and I'm also equally sure that you can see the bite on the Y star tracker.
That's a firm WEX. That's due to a low pressure in the tracker. No action.
Okay, we copy. Houston, Columbia.
Go ahead, Columbia. Columbia, Houston, we're experiencing some comm dropouts. Go ahead.
Okay, we copy that.
Columbia, Houston, we're about 3 minutes from LOS at 1838, and we should have a good lock then.
Okay, 1838.
It's Mission Control, Houston, loss of signal through TDRS East. We'll reacquire in about 8 minutes.
Columbia, Houston, we have you through TDRS West. How do you read? Columbia, Houston, we have you through TDRS West. How do you read?
Read you loud and clear. Good morning.
Good morning. We should be experiencing these comm dropouts off and on for the first part of this pass. Hopefully it'll get a lot better in about 10 or 15 minutes.
We copy?
Go ahead, Columbia.
Do you have a readout of the ohms digitals down there?
Stand by, Wex. We'll check.
Houston, Columbia.
Go ahead, Jim.
Yeah, the only reason I asked that, just an interesting note, the right ohms fuel digital readout at liftoff was about 4% higher than the real value as was briefed, and now it reads 91, vice about 77, so just an interesting note, the error is about 14% now instead of 4.
Jim, we copy, and we'll take a look.
Yeah, that's the only thing I wanted to tell you. That's the only reason I asked that question. Thanks.
Jim, thanks for the heads up.
Houston, Columbia.
Go ahead, Columbia.
TJ, I'm going to start KU band antenna cable positioning at this time. If that's okay with you.
Jim, we copy. Stand by one. And Jim, you are go for cable positioning on the KU.
Okay, thanks a lot.
In Columbia, Houston, we understand that your IMAX opportunities for Rev 13 are no-go due to weather.
Okay, we copy. We'll try to get some in the future.
Roger that. Columbia, Houston, we have some words for you on your AFE session scheduled at MET 1945 when you're ready to copy.
Go ahead, Tammy.
Yeah, Bonnie, we would like you to use A15 for AFE in order to free up MO13 Quebec for your FEA photo TV ops scheduled a little bit later.
Okay, Tammy, say again the panel that you want us to put AF.
Columbia, Houston, we lost you there for a second. How do you read? Columbia, Houston for Bonnie.
Go ahead.
Yeah, Bonnie, again, we're experiencing some comm dropouts. We would like you to use Alpha 15 for AFE. How copy?
Okay, Tammy, we copy Alpha 15 for AFE.
That's affirmed, Bonnie. Columbia, Houston, we see about a 1 sigma drift in IMUs 1 and 3, and we're going to be uplinking compensation.
Okay, thanks a lot.
Mission Control Houston at 19 hours 28 minutes mission elapsed time. We've just uplinked some compensations to the inertial measurement units aboard Columbia. That's all been successfully received aboard the spacecraft. Meanwhile, some television data. Our next TV event will be a replay of Flight Day 1 activities. That will begin in a mission elapsed time of 21 hours 55 minutes, or about 4:30 a.m. Central, 5:30 a.m. Eastern. Crew is still in the front end of their day, coming out of their post-sleep timeline into the major events for the morning. Payload deploy upcoming in 5 hours 14 minutes and about 28 seconds. We'll also be doing a burn in about 56 minutes as part of our rendezvous with LDEF. The chase still on. Right now, LDEF is on orbit 32,385. Columbia on orbit 14. Both passing over the northwestern tip of South America. LDEF is a little more than 900 miles out in front of Columbia.
Columbia, Houston, we have a weather map of the Great Sandy Desert in Australia coming up to you on tags.
Okay, Tammy, we're looking for it.
And G. David, wanted to let you know that this opportunity is very close to the on-orbit burn, about 30 seconds prior, so we understand if you are not able to take advantage of this photo opportunity.
Tammy, we'll take a look at it and we'll do what we can.
Thanks, Dave.
That weather photo they're discussing is, of, again, the Great Sandy Desert in Australia. Purpose is to give the crew an insight a little ahead of time as to what the weather looks like on that part of the planet. That's in support of IMAX photo opportunities. That would be pretty close to the burn upcoming as part of our rendezvous phasing. Also, it may be moot, the INCO.
In Columbia, Houston, we think that we have a tags jam, and would like for you to take a look at it for us and let us know what you find.
Yeah, we concur, and Marcia's working it.
Thanks, Dan.
As we were going to say, it looks like we have a jam on the text and graphics system, and Commander Brandon Steiner reports Marcia Ivins is down there taking a look at it and seeing if she can clear it out.
Houston, Columbia for tags.
Go ahead, Marcia.
Well, I heard the thing go funk, and I looked inside, and there was no paper, and if you concur, I'll start working the MAL 2.8 alpha.
Marcia, we concur 2.8 alpha. Also, Marcia...
Okay, I cannot see any paper in the back.
Okay, Marcia, we copy. Also, we're interested to know whether or not y'all were able to get any AFE data takes yesterday.
That's negative.
Copy, thanks.
Mission Control Houston, we're standing by for Capcom Tammy Jernigan to read the
Houston,
pad for the upcoming burn.
Vector and Peg 7 load coming up to you. We also have your orbital maneuver pad for the NC2 burn when you're ready to copy.
Stand by, Tammy.
Standing by.
Okay, Tammy, go ahead.
Okay, Columbia, the orbital maneuver pad for the NC2 burn will be a right ohms burn. TV.
Break, Tammy.
Say again, Dave.
Stand by one, please.
Roger.
Okay, Tammy, I think we're ready now.
Okay, Dave. Your NC2 burn, the right ohms. TV roll 180, trim load pitch negative 0.3, left yaw positive 5.4, right yaw negative 5.6, weight 244,233, TIG 00/20:25:17.2, Peg 7 targets, Delta VX positive 006.7, Delta VY all balls, Delta VZ all balls, maneuver attitude roll 290, pitch 185, yaw 067, Delta V tote 006.7, Tigo 00:08, Vigo X positive 006.27, Vigo Y negative 001.40, Columbia standing by.
peeked through TIGO and didn't catch anything after that.
And Columbia, Houston, how do you read now?
Tammy, loud and clear.
And Dave, understand, copied TIGO 00:08.
That's affirmative.
Vigo X, positive 006.27. Vigo Y, negative 001.40. Vigo Z, positive 001.81. HA, 193. HP, positive 160. Notes. Ohms gimbal check. Post burn, left primary, right primary. RCS interconnect, right ohms to RCS. Down mode options, none. Ohms helium reg test, right ohms only. Alpha opened, Bravo closed. IMU deselect, NA, readback.
Okay, Houston, it's an orbital maneuver pad for NC2. Got a right ohms, TV roll 180, trim load negative 0.3 plus 5.4, negative 5.6. Weight 244233, TIG of 00/20:25:17.2. Pick 7 targets, Delta V X plus 006.7. Maneuver attitude, roll 290-185-067. Delta V tote 006.7. TIGO 00:08. Vigo X plus 006.27. Negative 001.40 plus 001.81. That'll give us an HA of 193 by plus 160. Ohms gimbal check. Left and right primary, both post burn. Notes RCS interconnect, right ohms to RCS. Download options none. For the ohms helium reg test, it'll be right ohms only, A open, B closed, and IMU deselect is NA.
Dave, that's a good readback.
And Tammy's got some tags words for you if you're ready.
Go ahead, Columbia.
Okay, we found the jam, and I tried to reload the paper, and I think it's up to you now because the KU is in control or in command.
Okay, Marcia, good work. Thanks.
Okay, and the jam light is on right now.
Okay, Marcia, we understand the jam light is on.
And do you want me to do an advance on it?
Marcia, stand by. I believe we're going to try that from down here. In Columbia, Houston, we would like for you to begin your maneuver to NC2 burn attitude at 2010.
Roger that, Houston.
This is Mission Control, Houston, 2 minutes 50 seconds before loss of signal through the eastern satellite. The burn pad just read up for the NC2 burn. NC stands for phasing maneuver. The C is for catch-up. The burn will take place through the right orbital maneuvering system engine. Weight of the orbiter at the time of the burn will be 244,233 pounds. Time of ignition, 20 hours, 25 minutes, 17.2 seconds mission elapsed time. Change in velocity, or delta V, will be 6.7 feet per second, resulting in an orbit for Columbia of 193 by 160 nautical miles. Right now, Columbia is at 193.7 by 155.5 nautical miles. The orbital period, 1 hour, 31 minutes, 9.9 seconds.
For Marcia.
She's listening.
We commanded a paper advance down here on tags. However, we're still showing the jam light on. We'd like for y'all to take another look. We're about a minute and a half from LOS, and we'll pick you up on the west side at 2016.
Okay, I saw you try to set it because the jam light went off and then went back on again, and I'll redo what I did. The mount procedure 2.8A says if the light is on, hit advance. Do you want me to do that? I mean, after I clear the jam again?
Marcia, that sounds like a good idea. We'd like you to hit advance after you clear.
Okay, try to have it fixed by the time you get back to us.
Super. See you on the west side.
About 40 seconds now before loss of signal. Columbia will be maneuvering to the NC2 burn attitude in about 3 minutes. That'll happen during the LOS, their maneuver to the attitude. Then the burn itself will take place just a few minutes after we reacquire through the western satellite. At 20 hours, 6 minutes mission elapsed time, this is Mission Control Houston.
Columbia Houston, we're back with you through TDRS. How do you read?
Roger, Danny, we have you loud and clear.
And Dan, we have you the same.
This is Mission Control, the Guidance Navigation Control Officer reports Columbia maneuvering to burn attitude. Ignition upcoming in 8 minutes, 14 seconds. This NC2 burn, although called a catch-up burn, actually is going to have the net effect of slowing down slightly the rate of closure between Columbia and LDEF. Reason being, our ascent gave us such a good trajectory that we're actually trying now to put the brakes on with an eye to setting up the right conditions for the final 3 orbits leading into the rendezvous. It's important that we have the right geometry during those last 3 revs as we close in on LDEF so that we can get the right angles between Columbia and the spacecraft that gives us good star tracker opportunities and allows us to get the right parallax so that we can set up those geometries correctly and get the right data fed into the ship's guidance, navigation, and control for those final phases. So this burn, by increasing the perigee relative to LDEF, will actually slow us down. It's the law of orbital mechanics that says you have to read backwards and upside down to understand what's going on. INCO reports it looks like the jam is cleared on the tags, and we'll play with that some more after the burn. Now 6 minutes, 16 seconds away.
Houston, Columbia for tags.
Go ahead, Marcia.
Okay, send me another one. I think I got it fixed.
Wilco.
And then I got some news on PCG for you.
Go ahead, Marcia. We're ready to copy.
We went to check the filters and the temperatures this morning, and it appeared that PCG was off. We traced the cable, and the DC cable out of MO52J was disconnected, and the power was off. And for the life of us, we cannot figure out how that happened. We replugged it. The cold rim came up at 18.5 degrees. It's cooling down now. The ambient rim, the regular rim, was at 21.8, which is where we left it last night. And we're at a loss to explain how it got unplugged.
Marcia, we copy. Thank you.
And stand by, and I'll give you the METs for when I replugged it.
Standing by.
GNC reports Columbia has arrived at burn attitude. Propulsion Systems Officer likes the configuration for the burn. We're 4 minutes away.
Okay, Tammy, here comes the PCG stuff if you're ready.
Marcia, go ahead. We're ready.
Okay, we completed the operations at an MET of 8:15 yesterday, and that was on the PCG-1 activation, and the rim temperature was 21.8.
Copy.
I looked at it this morning. It was 1932 when I replugged it and the PCG number 1 was still 21.8, and PCG number 2 was at 18.5.
Okay, Marcia, we copy all that. Thanks for the report.
And it's right now at 11.7 is number 2.
Okay, Marcia, copy 11.7 for number 2.
It's Mission Control Houston, ignition upcoming in 15 seconds for the NC2 burn. And we see the burn underway. This burn will change Columbia's velocity by 6.7 feet per second, and as we said, will actually slow down its rate of closure relative to LDEF.
Columbia, Houston, the NC2 burn looked great.
Okay, it looked good from here too.
In Columbia, Houston, we're uplinking a TAGS test message.
Okay, we're eagerly awaiting it.
So a good NC2 burn took place about 20 hours, 25 minutes mission elapsed time. Next major event, the deploy of the CENTCOM satellite. That'll be about 4 hours, 16 minutes from now. That'll be followed by a separation burn at 4 hours, 31 minutes from now. We also believe we've cleared the jam in the tags, so the test will be, we think, with this test message that's going up right now, a tags test message, see if we've cleared that jam, and then perhaps we can resume tags transmissions. At 20 hours, 27 minutes, this is Mission Control, Houston.
Houston, Columbia, 4 tags.
Go ahead, Marcia.
Got another thunk and got lots of rolling noises and no paper. And no jam light.
Okay, Marcia, we copy no paper and no jam light. We'll take a look.
Houston, Columbia.
Go ahead, Columbia.
Yes, if you have TV, we have a sunset coming at you.
Copy, thanks. In Columbia, we're standing by.
This is Mission Control Houston. We're about to receive some unscheduled television downlink. We're hoping to see an orbital sunrise. This is Mission Control Houston transmitting on the mission audio circuit. We're now seeing some live television from Columbia from the Delta camera aboard the payload bay. We're hoping shortly to see an orbital sunrise as Columbia nears the terminator over the southern Pacific, due east of Australia.
In Columbia, Houston, we appreciate the great video downlink, and we'd like for you now to check your tags tray again. We attempted to send another test message.
Okay, we'll do it. And Tammy, we don't find anything there.
Okay, copy, Columbia. Thank you.
This is Mission Control, temporary loss of signal. We're standing by to reacquire. A note to our television users, we will replay this standard broadcast signal at the conclusion of this downlink.
Is the jam light on the tags?
The jam light is not on, and it's gone thunk like 3 times, but I don't see any paper in it.
Okay, stand by 1. Columbia, Houston for Marcia.
Go ahead.
Marcia, we assume it's just not pulling the paper, so we'd like you to try and rethread the paper, and then we'll send another message.
Okay, and work.
This is Mission Control Houston. Well, that didn't work out too well. We went into blockage shortly after acquiring. We've now turned the satellite around and we're originating NASA Select from JSC once again, so your television transmission at sites other than JSC should be standard signal. Since that was such a brief pass and we weren't able to see the orbital sunrise. We'll refrain from replaying the television signal that you just saw.
Houston, Columbia.
Go ahead, Columbia.
Well, you got us. The tags was pumping paper through all along, except it's black, which makes sense now we think about it, and we didn't look like there was anything in there. So Marcia's back rethreading again, and I think we had fixed it.
Okay, Dan, thanks.
Houston, Columbia, we're ready for some tags.
Copy, Wex. Columbia, Houston, we would like you to do a page advance on tags until you get white paper.
We copy.
And Columbia, Houston, when that's complete, we'd like a count on the number of pages you advanced.
We'll go.
Houston, Columbia for tags.
Go ahead, Marcia.
I got one page to advance. Hit the advance again. Now I have the page image light on and no paper in the tray.
Okay, Marcia, we copy and we'll take another look. Columbia, Houston for Marcia.
Go ahead.
Yeah, Columbia, one more page advance should get you a sheet of paper out, and we'd again like you to take a look at it. And if it's not yet white, we'd like you to keep performing page advances until you get clean paper. You can expect to have to do 2 page advances per piece of paper.
Okay.
Columbia, Houston, we have new TDRS vectors coming up to you.
Okay, thanks.
Mission Control, Houston, 21 hours, 9 minutes. Mission elapsed time, handover from the west to the eastern satellite in about 30 seconds.
Columbia, Houston, we show that you have a camera selected for downlink.
Roger, Houston, I'm checking with Bonnie and seeing what she had in mind. In the meantime, we ran paper through the tags, took 10 sheets to get a white one, and they all came through, so maybe we're back in business.
Okay, Dan, we copy, and we'll send up a test message shortly.
Houston, Columbia.
Go ahead, Columbia.
Okay, Tammy, we had the flight deck camera looking down at FEA on for a while. FEA is in progress. We're just heating up, and hopefully in about 20 minutes we'll start seeing a zone. I've reselected camera D for downlink, but I'll give anything you want.
Bonnie, we copy. We didn't have any particular request in mind. We saw the camera selected for downlink, and we thought we'd ask you about it.
Okay, well, the cabin flight deck is hooked up and looking down at FEA. You're welcome to pick the cameras that you'd like.
Bonnie, we copy. Thanks.
This Mission Control, Houston, we are now taking some unscheduled television from the payload bay of Columbia, this originating from the Delta camera. Those persons viewing this signal outside of Johnson Space Center will be seeing a non-standard signal.
In Columbia, Houston, we'd like some words on the airborne particulate sampler when you get a chance. Columbia, Houston, we'd like some words on the airborne particulate sampler when you get a chance.
Okay, in the meantime, we got some good news and bad news on the last tags message. It was a good test message. Looks like it came through fine. The bad news is David is heartbroken because it's the old test pattern.
Dan, we appreciate the report and tell Dave that we'll have something better for him later on in the flight.
Okay.
Meanwhile, still taking television from Columbia. This from the flight deck. Flight deck camera is shifted to look down through the hatchway into the mid-deck, and we're looking down on Bonnie Dunbar as she works with the FEA experiment. We expect to...
Columbia, Houston, we have the flight deck camera on the downlink right now, and we have a nice view of Bonnie.
Okay, she's hard at work with her FEA experiment.
We will replay this downlink in standard format for our users elsewhere, television users elsewhere. However, it's a little hard to know when we'll replay this since this is unscheduled and we don't know the duration of the downlink, but we'll certainly let you know as soon as we're in the know ourselves. Mission Control Houston lost a signal from Columbia.
In Columbia, Houston, for your information, we have lost video downlink.
Roger.
It's Mission Control Houston, 19 and a half minutes remaining in this pass through the Eastern satellite. We've just concluded an unscheduled downlink from Columbia, and we've turned our public affairs satellite around, and NASA Select is now originating again from Johnson Space Center. Reminder to our television users, this will happen throughout the mission. When we do turn the satellite around to take some of the downlink television on this flight, those not viewing in the Johnson Space Center area because of our particular configuration will see a non-standard television signal. We apologize for that, but we'll try to keep you up to date on what's going on with the signal. We will also endeavor to replay the best of those non-standard transmissions so that our users elsewhere can get good, clean copies of the television. That indeed is our plan with this last downlink. We'll replay it 5 minutes after the hour.
Columbia, Houston, we have some words for you on the accumulator pressure on hydraulic system 1.
Okay, just a second, Houston.
Say again, Columbia.
I said just stand by just a second. Be right with you.
Roger.
Okay, Houston, we're ready.
Yeah, Dan, it looks like the accumulator on hydraulic system 1 is losing pressure. We suspect the unloader valve is leaking, as was briefed pre-flight, and we'll continue to monitor and report back to you. Also, we expect the circ pump to come on in about 5 minutes.
Okay, we've been noticing that, and we're figuring it was going to be too long before it would come on. Thanks.
You bet. Columbia, Houston, we're 2.5 minutes from LOS. We will have UHF through iOS for an additional 3 minutes. However, we won't call you unless you talk to us. We'll pick you up on Westside Tidris at 2154.
Okay, Tammy, we'll see you there.
This Mission Control Houston lost a signal upcoming through the Eastern satellite shortly. Then we'll have another 3 minutes or so through iOS, as Tammy Jernigan explained. Our next television event, meanwhile, on NASA Select will be a replay of the Flight Day 1 activities. That replay will begin at a mission elapsed time of 21 hours, 55 minutes, or 4:30 a.m. Central Standard Time.
Columbia, Houston, we're with you through TDRS. How do you read?
Loud and clear. Houston, Columbia.
Go ahead, Columbia.
Roger, an update from the mid-deck.
We're ready to copy.
And Houston, we're trying to take care of a squeal, which is why I paused there. I deployed the STS DSO-471. When I took it out of the container and powered it out, the potentiometer was not locked. The pressure was 1.09, and the potentiometer was 7.85. So I cranked the pot down until the pressure read 0.93. The potentiometer at that time was 5.04, and I locked it in that place. And in the next 2 minutes, and by the way, it had already been powered on for about 5 or 6 minutes then. The pressure looked like it slowly increased, which I guess I was not expecting, but it didn't increase too much. Went from like 0.93 to 0.94 or 5. And it is now deployed, sitting next to its buddy on MF-71 Charlie.
Okay, Wicks, we copy, and thanks for the report.
And Bonnie's going to give you an update on FEA.
Okay, we're standing by.
Okay, Tammy, 49 watts was the final stable reading. We stayed at that till about 5 minutes ago. I went up to 51. The temperature's still pretty stable at, and it looks like the surface is starting to melt now. I'm going to probably take it up 1 more watt here in a couple more minutes. Just a note of interest for the folks down there on the microgravity disturbance experiment. I think the launch loads deformed the sample slightly. It looks like it has a slight bend in it, although I can't tell whether or not it's contacting the core sample.
Bonnie, we copy. Thanks.
And Tammy, AFE is in progress at this time with Marcia operating on Dave. And I'll give you an update later.
Okay, appreciate it.
Mission Control Houston at 22 hours, 23 minutes mission elapsed time. That concludes our replay of Flight Day 1 activities. We're now back live with you from Johnson Space Center. Columbia is now within coverage of the western TDRS satellite, midway between the continent of Australia, passing out over the Pacific Ocean, nearing the terminator and nearing the equator and inception of orbit 16. Very quiet here in the control center and aboard Columbia as we were taking that replay. Just about the only transmission during that NASA Select replay was from Dunbar, who reported that on the microgravity effects experiment, it looks as if, in her view, one of the samples may have become slightly deformed from launch loads, which, if so, would not be unexpected. Still counting down to deploy of the CENTCOM satellite in 2 hours, 19 minutes, 19 seconds. Ignition for the separation burn so that we can move away from that part of space as the preparations continue for the perigee kick motor firing on CENTCOM, and that separation burn by Columbia will be in 2 hours, 33 minutes. 58 minutes remaining in this pass through TDRS, and this is Mission Control Houston.
Go ahead, Columbia.
Yeah, Tammy, I have some notes for the radio limit experiment, and I think I'm going to shut down that here in a few minutes if you're ready to copy.
Bonnie, we're ready when you are.
Okay, I took the power up to 60 watts with a final temperature on the heater of 263. At 60 watts, you can see some definite motion of a zone, which is actually about 3 inches. However, the scribe lines remain. The horizontal lines or circumferential lines actually don't deform very much, but those that ran longitudinally almost filled in. In addition, there seems to be some surface texture changes, a little bit mottled where it is clearly starting to melt, and I can't tell whether it's an oxide or a different material, but it's a definite difference, and I've got some pictures. I think taking the watts up any further than that will just continue to surface melt down towards the ends, and I'm not sure we'll actually get a separation.
Bonnie, we copy and thank you for the report. Also, a note of interest, it looks like the Indian rods had slight bends in them prior to launch due to some pre-launch handling. However, additional deformation of the Indian may have occurred during launch, and we expect number 1 and 4 to have been affected. So you might want to take a look at sample number 4 before you process it.
Okay, I'll do that.
The signal as we hand over between the eastern and western, between the west and eastern satellites.
Columbia?
Go ahead, Columbia. We lost you momentarily in handover, but we're ready to copy now.
One additional note, even though we have an area protected down there, there is some residual vehicle motion, and I was able to detect that 3-inch spread of the zone, even if it was internally molten, just by movement of it.
Okay, Bonnie, thank you for the report.
This is Mission Control Houston at 22 hours, 55 minutes mission elapsed time. Columbia now out over the Atlantic Ocean between the United States and Africa, still catching up with LDEF, trailing by a little more than 900 miles. Our next television is in association with a major event of today, the CENTCOM deploy. We'll attempt on orbit 16 through TDRS West to get some views of the pre-deploy activities aboard the orbiter. We expect our television downlink to take place at 23:31 mission elapsed time, or 6:06 a.m. Central. This television will come to us on a circuit which will mean we don't have to mess around with replays for our users elsewhere. So we invite you to watch, and you should expect that television to be a standard NTSC signal.
Yep.
Go ahead, Columbia.
Okay, Tammy, we terminated the MDE at 22:55, and for the hardware folks, the high temperature was the power supply amp board at 50, and the front wall was reading 37. The final wattage was 72 with a heater temperature of 284, and again, still surface melting. Did appear to have some necking towards the center of the heater, but I think it would have taken quite a bit longer before we'd had any breakage.
Okay, Bonnie, we copy. Thanks. Columbia, Houston, we have some good news for you concerning your CENTCOM deploy.
Houston, Columbia, we're ready.
Yeah, Dave, the customers and the flight controllers have reviewed all the systems. There are no changes to the flight rule summary, and you are go to press and to deploy operations per the timeline.
Okay, Tammy, that is good news. And can you give us a preliminary deploy time at this time?
You bet, Dave. Stand by one. In Columbia, Houston, for Dave, we have a preliminary deploy time for you.
And I'm ready to copy.
Dave, this is also a final deploy time. 1 day, 0 hours, 43 minutes, 37 seconds.
Tammy, I copy. 1 day, 0 hours, 41 minutes, and 37 seconds.
Dave, that's 43 minutes.
Okay, we'll change that to 43 minutes and 37 seconds.
Good readback.
Mission Control Houston. So with 10 minutes remaining in this pass through the tracking and data relay satellite, the crew of Columbia was given a go to set aside their flight plan and pick up their CENTCOM deploy checklist and enter into the pre-deploy procedures when that timeline calls for it. The systems all look good aboard CENTCOM and all look good aboard Columbia to support the deploy, which will take place at a mission elapsed time of 1 day, 0 hours, 43 minutes, and 37 seconds. That is 1 hour and 30 minutes from now. The separation burn will take place 15 minutes later, or 1 hour and 45 minutes from now. 9.5 minutes left in this pass through Tidris East, and this is Mission Control Houston.
Columbia, Houston, we have your CENTCOM deploy pad and also your orbit maneuver pad when you're ready to copy.
Tammy, we're ready to copy right now.
Okay, Dave, the CENTCOM deploy pad for a 17 Delta deploy. Deploy time MET of 001/00:43:37. Deploy attitude, roll 108.96, pitch 207.98, yaw 323.94, window protect Omicron 010.18. Read back.
Okay, Tammy, I got deploy time MET of 001/00:43:37. Deploy attitude 108.96, 207.98, 323.94, and our window protect Omicron is 010.18.
Dave, that's a good read back. And let me know when you're ready for your orbital maneuver pad.
We're ready right now.
In Columbia, Houston, you have PEG 7s and orbiter targets coming up.
Okay, copy.
And Dave, are you still ready for the maneuver pad?
Yes, I am.
Okay. A left ohms burn, TV roll 180, trim load pitch negative 0.4, left yaw positive 5.2, right yaw negative 5.4, weight 228.754, TIG 01/00:58:37.0, PEG 7 targets, Delta VX positive 017.3, Delta VY all balls, Delta VZ negative 005.0, maneuver attitude roll 351, pitch 125, yaw 059er, Delta V tote 018.0, TIGO 00:21, Vigo X positive 016.93, Vigo Y positive 003.65, Vigo Z positive 004.92, HA 193, HP positive 169er. Notes, ohms gimbal checks post-burn, left primary, and right second. Change my last. Post-burn gimbal checks, left primary and right primary. RCS interconnect, right ohms to RCS. Down mode options, 1 ohms to RCS, full SEP. And in the event of a down mode, do not reconfigure the propellant system. Ohms helium reg test, left ohms helium press vapor isols, alpha open, Bravo closed, IMU deselect, NA. Readback.
Okay, Tommy, copy that. That's a left ohms burn, TV roll 180, trim load pitch negative 0.4 plus 5.2, negative 5.4, 228-754-01/00:58:37.0. Peg 7 targets plus 017.3, all balls, negative 005.0. Maneuver attitude 351-125-059er, Delta V tote 018.000:21, Vigo X plus 016.93 plus 003.65 plus 004.92. That'll give us a 193 by 169er orbit. The ohms gimbal check post burn left primary and right primary. RCS interconnect right ohms to RCS. Down mode options 1 ohms to RCS, full SEP, and in the event that we do have to down mode, you do not want us to reconfigure the prop system. Ohms helium reg test will be left. For the left ohms engine, it'll be A open, B closed, and IME deselect is NA.
Dave, that's a good readback. Just in time. We're 1 minute from LOS. We'll pick you up on the west side at 23:30.
See you then.
It's Mission Control Houston. We're about 30 seconds from loss of signal through Tidris East. A reminder, our next shuttle television on orbit 16 will come to us via Tidris West. We hope to see CENTCOM pre-deploy activities at that time. That should be at 23:31 mission elapsed time, or about 6:06 this morning Central. This is Mission Control Houston.